Hello and welcome to Pre-Algebra Practice Set 17. In this video, we're going to look at some additional practice problems for our lesson on the introduction to integers. So for the first few problems, we want to replace each question mark with the inequality symbol less than or greater than. So we begin with -2 question mark -4. So again, as I told you in the lesson, kind of the way you think about negatives, as you get bigger negatives, you're actually getting smaller numbers. Remember that if a number lies to the left of another number on the number line, it's actually a smaller number. So the numbers are decreasing this way. And again, you can also think about it, numbers increase this way. So if a number is to the right of another number on the number line, it's a bigger number. So when we think about -2 and -4, so -2 is here, -4 is here. -4 is to the left of -2 on the number line, so it's a smaller number. So we have -2 and we have -4. So remember, we want to use the inequality symbol that points to the smaller number. Again, -4 is smaller. It's to the left of -2. So we're going to use the greater than symbol because that's the one that's going to point to -4. So -2 is greater than -4. What about -5 question mark 0? So here's 0 on the number line. Here's -5. -5 is to the left of 0 on the number line, so it's a smaller number. Or you could have also said 0 is to the right of -5 on the number line, so it's a bigger number. Again, we want the symbol to point to the smaller number. So I'm going to use the less than symbol because that's going to point to the -5. So -5 is less than 0. Okay, let's take a look at -10 question mark -20. So we don't have a number line here. We're just going to reason our way through this. If we had the numbers 10 and 20, let's think about their relationship. 10 is a smaller number. If I have $10 in my pocket, I have less money than if I have 20. So we would say 10 is less than 20 like that. But if these numbers were negative, the reverse would be true. So -10 would not be less than -20. It would actually be greater than. -10 represents a smaller negative, and therefore it is more than -20. As these negatives get bigger and bigger, you're getting smaller numbers. We're going to the left on the number line that way. And you can also think about this using money. If I owe $20, I'm worse off than if I only owe 10. Right? I'm worse off in this scenario. Okay, now we want to find the opposite of each number. And recall, to find the opposite or the additive inverse of a number, you just change the sign. That's all we're going to do here. So we're going to start out with -5. The opposite of -5 would be +5. So I just write 5. Then we have 7. The opposite of 7 would be -7. Then we have -12. The opposite of -12 would be +12. Then we have 55. The opposite of 55 would be -55. Again, all we're doing is just changing the sign. Okay, now we want to simplify. And essentially what we do when we have problems like this, we're just using our knowledge of taking the opposite of a number, but we're applying it without actually asking that question. We're using symbols to say, hey, what is the opposite? What is the opposite of whatever's inside the parentheses? And in this case, it's -12. So if I asked you, what is the opposite of -12? You would reply 12. So that's all this is doing. It's just saying, hey, change the sign of whatever's inside the parentheses. Okay, now we have the opposite of -18. And in the lesson, I showed you a trick. When you start getting a lot of these symbols in a row, you can count how many symbols you have. So even though this is the opposite of -18, or you could say the negative of -18, however you want to think about it, you have 3 of these symbols. 3 is an odd number. Again, it's a number that's not divisible by 2, so we know the result would be negative. So this would be -18. You can kind of reason your way through this. Each time you have a pair of negatives, you end up with a positive. So the opposite of -18 would give you +18. Then when you get to this negative, +18 becomes negative again, and you have no more negatives out there to pair with that to make it positive. So an odd number of negatives will yield a negative result. Okay, here we have the opposite of, and then inside of parentheses we have 9 minus 7. So all this is telling me to do is, hey, do the operation 9 minus 7 first, and then when you're done, take the opposite of it. So 9 minus 7 is 2, and then the opposite of that The opposite of that is negative 2. Okay, now we have one of those ridiculously long ones. So we have the opposite of, 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 the opposite of negative 37. Okay, so how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 is an even number. It's divisible by 2. 8 divided by 2 is 4, no remainder. So I know that the result here will be positive. So this is going to be positive 37. And you can kind of think about this using pairs of negatives. So this would become positive, 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 and then positive, right? If I go from here to here, it becomes positive. Here to here, it becomes negative, but then positive again. Here it becomes negative, but then positive. Negative, and then finally positive. So each pair of negatives makes a positive. So when we have 1, 2, 3, 4 of those pairs and nothing left over, we get a positive result, right? If I added another negative out there, you would have 9 of them, and you'd basically have 4 pairs and then kind of 1 left over that you can't make into a pair. Again, an odd number of these, so you get a negative result. Hello and welcome to Pre-Algebra Test Section 1 on the Introduction to Integers. Okay, so for the problems in this video, we want to just replace the question mark with the inequality symbol less than or greater than. So we start out with a -1 question mark -2. So when we look at the negatives here, we see that -1 is here, and we see that -2 is here. So remember, as you move left on the number line, the numbers are getting smaller. And when we work with negatives, at first it seems a little confusing because we're used to 2 being bigger than 1. But because they're negative, bigger negatives mean smaller numbers. So what happens is -2 is a bigger negative, is to the left of -1 on the number line, so it's a smaller number. So we would have -1 and -2 here. And remember, we're going to use the symbol that points to the smaller number, so we're going to use the greater than, because the greater than would point to -2, and again, that's the smaller number. So -1 is greater than -2. What about -4 question mark 0? So -4 is here, and 0 is here. -4 is to the left of 0 on the number line, so it is the smaller number. And again, without using a number line, you can kind of just reason through this. If I have $0 in my wallet, meaning I have no money, I am better off, I have more, than if I owe $4, right? -4 could be used to represent a debt of $4. So -4 is a smaller number, so we're going to point the symbol towards -4. So we're going to be using a less than. -4 is less than 0. All right, here we have 2 question mark -2. So 2 is here and -2 is here. This one's really easy even without using a number line because you know if you have $2, it's more than if you owed $2. So 2 is clearly the bigger number. And again, you can see that by looking at the fact that 2 is to the right of -2. So you could say it's bigger. Or kind of flipping that around, you could say, okay, well, -2 is to the left of 2, so you know that it's smaller. So we have 2 and -2. Remember, the symbol is going to point to the smaller number. So it's going to point to the -2. So I want to use a greater than. So 2 is greater than -2. We have -90 question mark -20. So I want to think about this in terms of, let's make these numbers positive. Let's pretend we have 90 and we have 20. What's the relationship between these numbers? Well, it's easy to say that 90 is greater than 20, right? If I have $90 in my wallet, I have a lot more than if I only have 20. If I flip this around and say, okay, well, now I'm working with negatives, it's no longer true. And I wouldn't say that -90 is greater than -20. That's not true. I'd have to flip this around. -90 would now be the smaller number because it's a bigger negative, right? It's a bigger negative. -90 would be less than -20. Again, think about this in terms of money. If I owe $20, I am better off than if I owe $90, okay? I am better off than if I owe $90. And if you think about kind of visualizing this on a number line, we don't need to go through and make, a number line other than, let's do like a simple one with 0 here. I don't know, let's say -20 is here. We know -90 is to the left, right? Because we would count this way. So -90 could be somewhere over here. It's to the left of -20. It's a bigger negative, and therefore it's a smaller number. So -90 is less than -20. Hello, and welcome to Pre-Algebra Test Section 2 on the Introduction to Integers. Okay, so for the problems that we're going to look at in this video, we want to replace the question mark with the inequality symbol less than or greater than. So we're going to begin with -6 question mark -3. So if we look on our number line, we see that -6 is here and -3 is here. So what do we know about the number line and the relationship between numbers? We know as we move to the left, numbers get smaller. So meaning that if -6 is to the left of -3 on the number line, it is a smaller number. And this may be a little counterintuitive for you at first because you're used to 6 being bigger than 3. But when we think about negative numbers, the bigger a negative is, the smaller it actually is. So -6 is less than -3. And again, I'm using the less than there because I want the symbol that's going to point to the smaller number, and -6 is the smaller number in this case. What about 0 question mark -1? So looking at the number line, 0 is here, -1 is here. -1 is to the left of 0 on the number line, so it's a smaller number. Or you could say 0 is to the right of -1 on the number line, so it's a bigger number. So you have 0 and you have -1. And again, you want to point the symbol to the smaller number. So that means I'm going to use a greater than because I want to point the symbol towards the -1. So 0 is greater than -1. Okay, what about -2 question mark -18? So we have a number line here, but we don't see -18 there. We see -2 here. But you can kind of use this to think, okay, well, this is decreasing in increments of 1. So you'd have -9, then -10, then -11. -18 would be this way, right? It would lie to the left of -2 on the number line. That's all the information we actually need. -18 is a bigger negative, and so it's a smaller number. So we would have -2 is greater than -18. Again, use the symbol that's going to point to the smaller number. In this case, the smaller number is -18. All right, for the last one, we don't have a number line. We have -615 question mark -2000. So again, use your reasoning. If you owe $615, you owe less than if you owe $2,000. So this is a bigger number than -615. The -2000 is a smaller number. So I want to point the symbol to the smaller number, and I would use a greater than. So -615 is greater than -2000. Again, as negative numbers get bigger, they represent smaller values. So this one is actually smaller than this one. Hello and welcome to Pre-Algebra Test Section 3 on the Introduction to Integers. Okay, so for our problems, we're going to do something very, very easy. We just want to find the opposite of each number. So to find the opposite of a number, you just change the sign of the number. So for example, where we start out here with 12. If I want to ask, what is the opposite of 12? It's just -12, right? It goes from positive to negative. What is the opposite of 9? Well, it's just -9. I change the sign from positive to negative. What is the opposite of -4? Well, I change the sign from negative to positive, so this would just be 4. What is the opposite of -1? Well, I change the sign from negative to positive, so it would just be 1. What is the opposite of 1045? I change the sign from positive to negative, so I'd have -1045. Now, what is the opposite of 87? So again, I just change the sign. So from positive to negative. So the opposite of 87 is -87. And then for the last one, what is the opposite of -132? It's just 132. Hello and welcome to Pre-Algebra Test Section 4 on the Introduction to Integers. So for the problems we're going to look at, we just want to simplify. And we're going to start out with the opposite of -7. Or you could say the negative of -7, however you want to think about that. Essentially what this symbol right here, this negative symbol is telling you is you want to change the sign of whatever's inside the parentheses. So I have a -7 inside the parentheses. So hey, change the sign of that. It would become +7. So again, the opposite of -7 would be 7. Okay, so now we have the opposite, or we could say the negative of, and then inside of parentheses we have 4 plus 7 times 2. So when you get a problem like this, just think back to your order of operations. You want to work inside the parentheses first. So we'll kind of leave this negative for last. So if I look inside the parentheses here, I see that I have addition and multiplication. We know from our order of operations lesson that multiplication is the higher priority. So we would do 7 times 2 first. So 7 times 2 is 14. So I'm just going to replace that with a 14. So we'd have 4 plus 14. If I perform that operation, I would get 18, right? 4 plus 14 is 18. So I'd have my negative symbol out in front, and then an 18 inside of the parentheses. And now I just have a negative that's hanging out in front of a set of parentheses. It's basically just saying, hey, find the opposite of whatever's inside the parentheses. So what is the opposite of 18? Well, it's just negative 18. Okay, now we have a problem that can be kind of tedious if you don't use the shortcut that I covered in the lesson. So we have the opposite of, the opposite of, the opposite of, the opposite of negative 29. So kind of the shortcut is to look through and see how many of these symbols you have. So I count 1, 2, 3, 4, 5 of them. 5 is an odd number, right? It's not divisible by 2. 5 divided by 2 is 2 with a remainder of 1. So what happens is you end up with a negative result. So you would end up with negative 29. Now, kind of reasoning your way through this, each pair of negatives would make a positive. So there I have 2 pairs, or kind of a total of 4 signs. And when you get out to this one right here, you would end up with a negative and nothing to pair with it to make it positive again. So you can think about it that way. You can do this the long way. You can start inside with negative 29 and kind of work your way outside. So this guy right here would make this positive. Then this would make it negative, then positive, and then negative for the final answer. So we end up with negative 29 as a result. Okay, now we have the opposite of, the opposite of, the opposite of, the opposite of, and then inside of parentheses, 13 minus 7. So for this one, we want to just do the operation inside of the parentheses first. And then when we're done, we can use our shortcut. We have 1, 2, 3, 4 of these guys. 4 is an even number, right? 4 divided by 2 is 2, no remainder. And so if you get an even number of these signs, you're going to end up with a positive result. So I know what's inside of the parentheses is 6. So once I apply that shortcut, I would just have positive 6. Okay, now if we wanted to do this the slow way, we can kind of start by just doing this operation in here. So let me just copy all this again. The opposite of, the opposite of, the opposite of, the opposite of, and then inside the parentheses would replace that with a 6. And now we could work our way outward. So this would become negative, then positive, then negative, and then finally positive. So again, either way you do it, you end up with positive 6 as your answer. Hello and welcome to Pre-Algebra Test Section 5 on the Introduction to Integers. Okay, so for the problems in this video, we just want to simplify. We're going to start out with the opposite of negative 912. So as you'll recall in the lesson, I gave you a little shortcut for solving a problem like this. All you need to do is count the number of negative symbols that you see in the problem, and then if the number is odd, the result is negative. If the number is even, the result is positive. Here you have 3 of them. You have 1, 2, 3. That's an odd number, and so the result would be negative. So I could just write negative 912 and be done. Now, kind of the slower way to do this would be to start at the innermost set of parentheses. So start with the negative 912, and you'll work your way outward. So in other words, you would go out here and say, okay, well, this is the opposite of negative 912. So that makes it positive. And then we would do that one more time. We would say, okay, I want the opposite of the result of what we just found, which was positive 912. That would change the sign again. It would become negative 912. Okay, now we have the opposite of 4 squared minus 15. So what we'd need to do is actually figure out what 4 squared minus 15 is first, and then we can use our little trick. So 4 squared would be done first because of the order of operations. We do exponents before subtraction. 4 squared is 4 times 4, that's 16. So I'm going to rewrite this with the opposite of, and then we'd have 16 minus 15. Now, next, we're still working inside those parentheses. We have 16 minus 15. That's going to give us 1. So we'd have the opposite of, the number 1. And now we can just count the number of these symbols that we have. We have 1, 2 of them. 2 is an even number, so the result would be positive. And alternatively, you could have just said, okay, well, I want the opposite of 1. That's going to be negative 1. And then I want the opposite of negative 1. That's going to give me positive 1. And some of you might be saying, well, how come I didn't include this symbol in here? Well, this is subtraction, right? When you have an operation that you're doing inside the parentheses there, just do the operation first. And then once you have a single number left, you can use that little trick. Okay, now we have one that's fairly ridiculous. And you might get this on your test, so it's good to practice. We have the opposite of, 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 the opposite of negative 1037. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is an odd number, so this will be negative. This will be negative 1037. And I'm not going to do it, but you can go and work backwards if you want. You can start inside the parentheses here with negative 1037 and go, okay, well, this would make it positive, then negative, then positive, so on and so forth till you get all the way down there, and you would see that you would end up with a negative. Hello and welcome to Pre-Algebra Practice Set number 18. In this video, we're going to look at some additional practice problems for our lesson on absolute value. Okay, so we want to find the absolute value, and we're going to start out with the absolute value of negative 7. So as I told you in the lesson, to find the absolute value of a number, it's very, very simple. If the number is negative, just make it positive. If the number is 0 or positive, it's just that number. So if I want to find the absolute value of negative 7, since it's negative, I just make it positive. So just kind of think about, okay, it's negative 7, now it's positive 7. And that's it. That's all there is to it. So what is the absolute value of negative 12? Again, it's a negative number, so just make it positive. So the absolute value of negative 12 will just be 12. What is the absolute value of 35? Well, now we have a positive number, and essentially if you have a positive number, it's just that number. So the absolute value of 35 is 35. Here's one that trips people up a lot. What is the absolute value of 0? And I did it twice in the lesson just to make sure that you knew that the absolute value of 0 is 0. And again, the reason for this is if you look on a number line, kind of with the basic definition, if I ask you for the absolute value of 1, it's 1 because it's 1 unit away from 0 on the number line. If I ask you for the absolute value of 0, it's 0 because 0 is 0 units away from 0 on the number line, right? It's no units away from itself on the number line. So the answer there is just 0. What about the absolute value of negative 715? Again, we have a negative number, so just make it positive. So the answer would be positive 715. And then for the last one, what is the absolute value of negative 2,212,513? Well, again, it's a negative number, so we're just going to make it positive. So it would be positive 2,212,513. All right, now we're going to look at some different problems. We want to replace the question mark with less than, greater than, or equal to. So we start out with the absolute value of negative 92, question mark, the absolute value of 53. So which one of these guys is going to be bigger and which one is going to be smaller? Well, when we think about absolute value, remember, we're not going to have any negatives involved. So I can go through and think about negative 92 here. Because it's a negative and I'm taking the absolute value, it's going to become positive. So this would be positive 92. 53 is a positive number, so it's just going to stay the same. So when I compare 92 and 53, I know 92 is a bigger number, so I would use a greater than symbol here. Right? I want to point the symbol to the smaller number, so I would say the absolute value of negative 92, which is 92, is greater than the absolute value of 53, which again is 53. What about the absolute value of negative 15, question mark, the absolute value of 15? Well, once we take the absolute value here, we're going to see that we have the same number, right? Because the absolute value of negative 15 is 15. The absolute value of 15 is 15. Remember, if you have opposites, which in this case is negative 15 and 15, they're opposites, they have the exact same absolute value. So we'd use an equal sign here. So the absolute value of negative 15 is going to be equal to the absolute value of positive 15. Okay, what about the absolute value of 0, question mark, the absolute value of negative 34? Well, the absolute value of 0 is 0. The absolute value of negative 34, again, is just going to be 34. Right? For a negative, you just make it positive. So the absolute value of 0 is going to be smaller or less than the absolute value of negative 34. Again, always point that symbol to the smaller number. In this case, the smaller number is 0. Okay, we have the absolute value of negative 81, question mark, and then we have the absolute value of 85 minus 4. So the absolute value of negative 81 is 81, right? If it's negative, just make it positive. And then 85 minus 4 is 81. And if we took the absolute value of that, we would get 81 as well. So these two values will be equal. So the absolute value of negative 81 is equal to the absolute value of 85 minus 4. In each case, once you go through the operations that are involved, you would have a value of 81, right? So those two are equal. Okay, now we're just going to simplify. And so we're going to start out with the opposite of, and then we have the absolute value of negative 17. Now, I warned you about this in the lesson. You have problems where you'll see the opposite of negative 17 like this. No absolute value bars involved. What I've told you is the shortcut is you can count the number of these symbols you have, the number of negatives. If it's even, it's going to be a positive number. If it's odd, it's going to be a negative number. So here you have two of those symbols. 2's even, so you get positive 17. In this case, you will not get a positive 17. You might go through and say, okay, I have 1, 2 of these symbols and positive 17. No, that's wrong. And here's the reason. When you have the absolute value operation involved, remember, the result of this guy right here is always going to be non-negative, meaning it's 0 or larger. So you can't ever count the negative that's inside of the absolute value operation because it's going to make it into a positive number. So what we have to do is just count the ones that are outside. So if I just count here, I have 1 that's outside, 1's an odd number, so this would end up being negative 17. Going through this the slow way, you can just evaluate. The absolute value of negative 17 is 17, so I would have the negative of, or the opposite of, 17, and then I would just change the sign. So it would go from positive 17 to negative 17, and that would be my answer. Okay, here we have the opposite of, and then inside of the absolute value operation, we have 5 plus and then 7 squared. Okay, so the opposite of the absolute value of 5 plus 7 squared. Inside of these absolute value bars is where we would start. And remember the order of operations. If you have addition and you have an exponent, you do the exponent first. So 7 squared is 7 times 7. I think we all know at this point that's 49. So I would write this as the opposite of the absolute value of 5 plus 49. Now we can do our addition. 5 plus 49 is 54. So this would be the opposite of the absolute value of 54. And then the absolute value of 54 is just 54, right? If it's a positive number, it's just itself. So we'd have the opposite of 54. And then we just take the opposite of 54 and we end up with negative 54 as our answer. Now we have the opposite of, the opposite of, the opposite of, and then inside of absolute value bars, 35 minus 2 squared. So I'm going to think about what's in the absolute value bars first. Okay, what's in the absolute value bars first? And then if I look outward, I know I have 1, 2, 3 symbols that are going to be involved. 3 is an odd number. So I know in the end it's going to be a negative result. But I got to find out what the value is for inside the absolute value bars first. So if I look in here, I have 2 operations. I have subtraction and an exponent. So I know I want to do the exponent first. So the opposite of, the opposite of, the opposite of, and then inside the absolute value bars, we're going to have 35 minus 2 squared is 2 times 2, that's 4. So minus 4. And so now working inside the absolute value operation, 35 minus 4 is 31. So we'd have the opposite of, the opposite of, the opposite of, and then the absolute value of 31. Now I can just take the absolute value of 31, that's 31. But really, I don't even need to do that at this point. If I see the absolute value of just a number, and I know what negatives are outside, I can just use my shortcut. I know the answer would just be negative 31. So once you get comfortable with that, you can go ahead and stop at this point and write your answer. But again, the slow way, replace this with 31. So we'd have the opposite of, the opposite of, the opposite of 31. So now we would change the sign here. So the opposite of 31 would be negative 31. So we'd have the opposite of negative 31. Change the sign again. The opposite of negative 31 would be positive 31. So we'd have the opposite of positive 31. Change the sign one more time. The opposite of 31 is negative 31. And that will be our answer. But again, once you get to this step and you know what number is going to be inside the absolute value operation, you can use your shortcut. Absolute value just makes the number 0 or positive. So you can just think about that number that's going to result, and then think about the negatives that are outside of that absolute value operation and get your answer. In this case, we knew the answer would be 31, and then we think about 1, 2, 3 of those guys. 3 is an odd number, so we would have a negative applied to it. So you'd have negative 31. Hello and welcome to Pre-Algebra Test Section 1 on absolute value. Okay, for the problems, we just want to find the absolute value for each. And finding the absolute value is very, very simple. If we have a negative number, we just make it positive. If we have a positive number or 0, we just keep it the same. So for the absolute value of negative 2,395, we just make it positive, right? Because it's a negative. So positive 2,395. That's all we need to do. We are done. What about the absolute value of negative 1? Well, again, if it's negative, just make it positive. So this would just be 1. What about the absolute value of 975? Well, this is a positive number, so it just stays the same. So it would just be 975. What about the absolute value of 641? Well, again, it's a positive number, so it just stays the same. So 641. What about the absolute value of negative 11? Well, again, if it's negative, you just make it positive. So the absolute value of negative 11 is 11. What about the absolute value of negative 18? The absolute value of negative 18 is just 18, right? If it's a negative value, just make it positive. And for the last one, what about the absolute value of 0? Again, if it's 0 or any positive number, just keep it the same. So the absolute value of 0 is 0. Hello and welcome to Pre-Algebra Test Section 2 on absolute value. Okay, now we want to just replace the question mark with less than, greater than, or equal to. So we're going to begin with the absolute value of negative 3, question mark, the absolute value of 25. So just think about this before you put the symbol in there. If I think about the absolute value of negative 3, it's just 3. Right? If you have a negative number, and you take the absolute value of it, you just make it positive. For the absolute value of 25, it's a positive number. So when you take the absolute value of a positive number, you just keep it the same. So this would be 25. So thinking about the relationship between 3 and 25, 3 is the smaller number. So I would use a less than here because the absolute value of negative 3 would be 3, and that is less than the absolute value of 25, which is 25. Again, the symbol always points to the smaller number. What about the absolute value of negative 7? Question mark, the absolute value of 15. Well, again, thinking about this, if we take the absolute value of a negative 7, it's just going to be positive 7. Right? You just make it positive. The absolute value of 15 will just be 15. Right? If it's a positive number, just keep it the same. And so we know 7 is the smaller number. So we're going to use a less than here. The absolute value of negative 7, which is 7, is less than the absolute value of 15, which is 15. Again, you point the symbol to the smaller number. What about the absolute value of 31? Question mark, the absolute value of negative 31. The absolute value of 31 and the absolute value of negative 31. Remember, these two numbers are what we call opposites. So they have the same distance from 0 on the number line, but they lie on opposite sides of the number line. We learned in our lesson that opposites have the exact same absolute value. So in each case, the result would be the same, right? The absolute value of 31 is 31. The absolute value of negative 31 is also 31. So these two are equal, right? Because when you do the absolute value operation, it ends up being 31 equals 31, right? The same number on each side. Here we have the absolute value of 752, question mark, the absolute value of negative 5,015. Okay, so again, thinking about these numbers, we know that the absolute value of 752, it's a positive number, is just 752. The absolute value of negative 5,015, if it's a negative, just make it positive, so it would be 5,015. Very, very easy to do. Clearly, this is the smaller number, so we would use a less than here, right? The absolute value of 752, which is 752, is less than the absolute value of negative 5,015, which is 5,015. Right? Again, use the symbol that points to the smaller value, and in this case, that's the absolute value of 752. Again, point the symbol towards the smaller number. So for the next one, we have the absolute value of 0, question mark, negative 25. So the absolute value of 0 and negative 25. Now notice how negative 25 is not inside of absolute value bars. We are not performing that operation here. So the absolute value of 0 is just 0. So if I think about 0 and negative 25, I know that 0 is a bigger number, right? I would use a greater than there. And again, the reasoning for this, if you owe nothing or have nothing, you're better off than if you owe $25 to somebody, right? If you have nothing, no debts, but you don't have anything, you're better off than if you owe somebody $25. So we're going to use a greater than here. The absolute value of 0 is greater than negative 25. Hello and welcome to Pre-Algebra Test Section 3 on absolute value. Okay, for the first problem, we have the absolute value of 75 plus 2 squared. Then we have our question mark. And then we have the absolute value of negative 79. So if we think about what the value will be after we apply the absolute value to the 75 plus 2 squared, well, we have multiple operations involved inside the absolute value bars. We have 2 squared and we have an addition. Now, exponents take the highest priority, so we would figure out what 2 squared is first. 2 squared is 4, so we would essentially have the absolute value of 75 plus 4. Now, 75 plus 4 is 79, and so we would have the absolute value of 79 there. Now, the absolute value of 79 is just 79. Now, looking over here, we have the absolute value of negative 79, and we know that's also 79, right? If you have a negative value and you take the absolute value of it, it just becomes positive. So these two are equal, right? Because they result in the same number, 79. So the absolute value of 75 plus 2 squared is going to be equal to the absolute value of negative 79. Right? Those two will, again, result in the number 79 once you've done everything. All right, for the next one, we have the absolute value of, and then we have 3 squared times 5 minus 7, then our question mark, and then the absolute value of negative 115. So I'll start over here because this one's really easy. The absolute value of negative 115 is just 115. And just think about the operations involved inside of the absolute value bars there. So we'd have 3 squared times 5 minus 7. You have an exponent, you have multiplication, and you have subtraction. The exponent is the highest priority. So 3 squared is 9, right? It's 3 times 3. So this would be 9, and then times 5 minus 7. Your next highest priority is multiplication. So you do 9 times 5 next. And 9 times 5 is 45, and then minus 7. And now you're just left with subtraction. 45 minus 7 is 38. So the result of this is going to be 38. Let's just write that there. Now, when you take the absolute value, of 38, you'd still get 38, right? Because the absolute value of a positive number is just itself. So thinking about 38 and 115, I know that 38 is the smaller number. So we're going to use a less than symbol here. So we would have the absolute value of 3 squared times 5 minus 7 is less than the absolute value of negative 115. And this is because, again, once we go through and perform all the operations involved, you'd end up with 38 is less than 115. Okay, for the next one, we have the absolute value of 10 squared divided by 4 plus 8. Then we have our question mark. And then we have the absolute value of 32. So again, this one's easy. The absolute value of 32 is just 32. And thinking about the operations in here, let's just figure out what's the result of what's inside the absolute value bars. So we have 10 squared divided by 4 plus 8. You have an exponent, you have division, and you have addition. So the exponent is the highest priority. So 10 squared is 10 times 10, that's 100. Then divided by 4 plus 8. Now, division is the next highest priority, right? You have division and addition. So 100 divided by 4 is 25. So we would say this is 25, then plus 8. And then our final operation would give me 33, right? 25 plus 8 is 33. So this would be 33. If we take the absolute value of 33, we get 33. So we're basically comparing 33 and 32, and we know 33 is bigger. So we would say that the absolute value of 10 squared divided by 4 plus 8 is greater than the absolute value of 32. And again, the result of this, once you've done everything, is 33. The result of this, once you've done everything, is 32. So 33 is greater than 32. That's why our symbol is pointing to the right, right? We have it pointing towards the smaller value. Okay, let's take a look at one final problem. So we have the absolute value of, and then inside of parentheses, we have 5 cubed divided by 5, then plus 11, question mark, and then we have the absolute value of 2 times this quantity 6 minus 4, then plus 9 squared. So we have to think about what's involved inside the absolute value bars in each case, and then come back, take the absolute value, and figure out, the relationship between the two. So let's just write this, forget about the absolute value bars for now. 5 cubed divided by 5 inside of parentheses plus 11. So in any problem, you always start out inside of parentheses. Once we're in there, we reapply the order of operations. We have division and we have an exponent. So we do the exponent first. So what is 5 cubed? What is 5 times 5? That's 25. Then times 5 again, that's 125. So we would have 125 divided by 5 plus 11. So this is inside of parentheses. This part is not. Now, we look inside the parentheses because, again, that's the highest priority in any problem. We just have the division. So 125 divided by 5 is going to put us back to 25. So now we'll have 25 plus 11. And then if we add these two, let's just do that vertically. So 25 plus 11, 5 plus 1 is 6, 2 plus 1 is 3. So that's 36. So after everything is said and done, the result of this right here, would be 36. Now, when we take the absolute value of 36, we get 36, right? Take the absolute value of a positive, you just get that number back. Now, working over here, we'll do the same thing. Forget about the absolute value bars. We'll have 2 times the quantity 6 minus 4, then plus 9 squared. Work inside the parentheses first. So you'd have 6 minus 4, and that's going to give you 2. So we would have 2 times 2, then plus 9 squared. And again, remember, when you have a number next to a set of parentheses, it implies multiplication. If you're more comfortable, we can write this like this, 2 times 2. Now, looking at the operations we have left, we have an exponent, we have addition, and we have multiplication. We need to do this exponent first. It's our highest priority. So 9 squared is 9 times 9, that's 81. So we'd have 2 times 2 plus 81. Now we have multiplication and addition. We want to multiply before we add. 2 times 2 is 4. So we'd have 4 plus 81. And if we do that, 4 plus 81 is 85. Okay, so the result of this right here is going to give us 85. So when we take the absolute value of 85, again, because it's a positive number, it stays positive. It's just going to be 85. So thinking about 36 and 85, 36 is smaller, right? 36 is going to be less than 85. So we're going to use a less than symbol here. Let me just rewrite this. We would have the absolute value of 5 cubed divided by 5, that's inside of parentheses here, plus 11 is going to be less than, remember, because the result of this was 36, the absolute value of 2, and then this is multiplied by this quantity, 6 minus 4, plus, and then we have 9 squared. Remember, this result was 85. So this is going to be less than this, because at the end of the day, once we've done all the operations involved, this result is going to be 36, and this result is going to be 85. So 36 is less than 85, so that's where we're using a less than here. Hello, and welcome to Pre-Algebra Test Section 4 on absolute value. Okay, for the problems we're going to look at, we just want to simplify. Okay, for the first problem we're going to look at, we have the opposite of the absolute value of negative 173. So some of you might immediately say, okay, I have 1, 2 of these symbols, 2 is an even number, so I know my answer is positive 173. That would be wrong here, and let me explain why. So if you recall, we did a lesson where we talked about integers and opposites. And we did some simplification there. So something like the opposite of negative 173. I could count the number of negatives I have. If it's an even number, the result is positive. So in this case, I have 2, that's even, I get 173. If I had another negative involved, then I would have 3 negatives. 3 is an odd number. The answer would be negative, all right? Each pair of negatives basically just makes a positive. So the opposite of negative 173, this would become positive, and then it would become negative. So we know that at this point. But if you try to apply that here, it's not going to work. And the reason is because you have to treat whatever you see here as a positive. Once you apply the absolute value operation, remember the result is never going to be negative. So you can't count the negative sign inside of the absolute value operation, because once you perform the absolute value operation, it's not going to exist. So just to see this, the absolute value of negative 173 is 173. So it would just have the opposite of 173, and that is negative 173, right? So if you have a problem like this, you just count the negatives outside of any absolute value bars that you have. You can't count the ones that are inside. Again, that's because I'm just looking at this problem here, the opposite of 173. Right? Once I apply the absolute value, it's going to make the number positive. So that's why we end up with this negative 173. Okay, now we have the opposite of, the opposite of, the opposite of, the opposite of, and then we have the absolute value of 3 to the 4th power minus 8. Okay, so what we would do here, we would perform the operations inside of the absolute value bars first. Once we get this down to a single number, where we're saying, okay, we're taking the absolute value of some number here, we could use our trick. We would just count the number of negatives we have outside the absolute value bars. In this case, we have 1, 2, 3, 4. 4 is an even number. So at the end of the day, the result is going to be positive, right? So let's just work on this part first. 3 to the 4th power minus 8. So I would perform this operation first, right? I would figure out what 3 to the 4th power is. And when I'm done with that, then I'm going to subtract away 8. So 3 to the 4th power is 3 times 3, that's 9, times 3 again, which is 27, times 3 one more time, which is 81. So we'd have 81 minus 8. So 81 minus 8 is 73. So I could replace this. Let me just rewrite all of this real quick. I can replace this with a 73. So the opposite of, the opposite of, the opposite of, the opposite of, and then the absolute value of 73. So once I get my problem to this point, I can stop because I can get the answer. I can look at this now and say, okay, I know the answer is positive 73. How did I know that? I have a single number inside the absolute value operation. I know that this makes it positive. And then I have 1, 2, 3, 4 negatives involved. 4 is an even number, so I'm going to have a positive result. So I could stop at this point and just say, okay, the answer is 73. Or I could go through it the long way. I could go through it the long way and say, okay, we're going to have the opposite of, the opposite of, the opposite of, the opposite of, and then this will be 73, right? The absolute value of 73 is just 73. Now we would go through and say, okay, this would make it negative, then positive, then negative, then positive. So again, we'd end up with just 73 as our answer. Okay, so let's think about this one. We have the opposite of, the opposite of, the opposite of, and then we have the absolute value of negative 212. All right, so if we think about this, again, it's a perfect place to use your trick. We know that the result of what's inside here is going to be positive, right? It's going to be positive. And in this case, it's going to be a positive 212. But even just ignoring that for a second, I would count the number of negatives that I have outside the absolute value operation. I see that I have 3. 3 is an odd number, so I'm going to end up with a negative result here. All I have to do is figure out what the result of the absolute value of negative 212 is, then just slap a negative on there, and I'm done. So the absolute value of negative 212 is 212, and so we end up with negative 212 as our answer. Again, if you want to go about this the slow way, take the absolute value first, so we'd have the opposite of, the opposite of, the opposite of. The result of this, the absolute value of negative 212 is 212. Now, starting here and just working your way outward, this would become negative, then positive, and then negative. So again, you'd end up with negative 212. Hello and welcome to Pre-Algebra Test Section 5 on absolute value. Okay, so we want to simplify. So we're looking at the opposite of, and then inside of parentheses here, we have the opposite of the absolute value of 2 squared divided by 4, then plus the absolute value of 5 plus 7. So kind of to start this problem, I would think about it using the order of operations. So I have this negative here, and then inside of the parentheses I have another negative, and then inside the absolute value bars I have 2 squared divided by 4. Now I want to apply that exponent before I divide. Exponents are a higher priority. So 2 squared is 2 times 2, that's 4. So I would write this as 4 divided by 4. And then plus, I'm just going to copy the rest of the problem, the absolute value of 5 plus 7. Now continuing, now I would do 4 divided by 4. 4 divided by 4 is just 1. So I'm going to replace this part right here with a 1. So the opposite of, and we have the absolute value of 1, and plus the absolute value of 5 plus 7. So then continuing, now the absolute value of 1 is just 1. So I'd have the opposite of the number 1. Okay, plus. Now we have the absolute value of 5 plus 7. We could just go ahead and do that. 5 plus 7 is 12. So we'd have the absolute value of 12. So now we have the opposite of the number 1. And then plus the absolute value of 12 would just be 12. Okay, so the opposite of 1 is negative 1. So I would have the opposite of negative 1 and then plus 12. So now the opposite of negative 1 is 1. So we'd have 1 plus 12, and this is just 13. All right, let's look at one more. We have the opposite of the absolute value of 6 squared divided by 9 plus 7. Okay, so let me just recopy this. The opposite of, and then the absolute value of. So inside of here, the highest priority is this exponent. So we'd have 6 squared, that's 6 times 6, that's 36. So I'm going to write 36 divided by 9 plus 7. Okay, continuing. If I look inside the absolute value bars now, my highest priority is that division. 36 divided by 9 is 4. So I'm going to have the opposite of, and then the absolute value of. This will be 4, then plus 7. And just to kind of make this shorter, I can just replace 4 plus 7 with 11. I don't need to do an extra step for that. So let's just make this 11. Okay. Now at this point, I have my answer. Okay, and you might be saying, what are you talking about? Well, look at what I have here. I have 1, 2, 3, 4 negatives that are outside of an absolute value operation that just contains a number. We know that when we take the absolute value of a positive number, it's just the number. So at this point, it's the same as if I just had the opposite of 11. And we know using our shortcut that that would just be 11, right? We don't need to go any further. But if you want to go about it the slow way, you can say, okay, well, this is going to be 11. So the opposite of. I'm going to put 11 inside of parentheses. And then we're going to work our way outward. So this would be negative, then positive, then negative, then positive. So again, we end up with positive 11. Hello and welcome to Pre-Algebra Practice Set number 19. And in this video, we're going to look at some additional practice problems for our lesson on adding integers. Okay, so we want to add using a number line, and we'll start out with 1 plus 6. So we all know how to do 1 plus 6. We start out at the leftmost number, which is 1. And then we're adding 6. So if we're adding a positive number, we're just moving to the right by that number of units. So what I'm going to do is I'm going to go to the right. I'm going to go 1, 2, 3, 4, 5, 6 units to the right, and we end up at 7. Right? So 1 plus 6 equals 7. And of course, we all know that. Okay, what if we had negative 2 plus negative 7? So we start out at the leftmost number, negative 2. So we're going to start out right here on our number line. Now I'm adding negative 7. So when I add a negative, I'm moving to the left. Just think about subtracting 7 units away. You'd move to the left 7 units. That's exactly what we're doing here. If we're adding a negative 7, it's the same thing as taking 7 away. I'm going to go to the left 7 units. 1, 2, 3, 4, 5, 6, and then 7. So I end up at negative 9. So negative 2 plus negative 7 equals negative 9. Okay, what if we had negative 1 plus negative 5? Again, we start out at the leftmost number, so we start out at negative 1. We're adding a negative 5. Okay, so we're just moving to the left by 5 units. Just think about adding a negative 5 as just subtracting 5 away. Okay, I'm taking 5 more away. So I'm going to go 5 units to the left. 1, 2, 3, 4, 5. Okay, I end up at negative 6. So negative 1 plus negative 5 is negative 6. And again, think about this using money. Let's say you owe $1 to your father and you owe $5 to your uncle. If you said, well, what's my total debt between these two people? Well, you could represent that with a negative 6. You could say, hey, I owe $6. Let's say I have 9 plus negative 8. So I start out at 9 on the number line. That's right here. And I'm adding a negative 8. So that means I'm moving to the left 8 units. Okay, again, if I'm adding a negative, I'm going to the left. So in this case, it's a negative 8. So I'm going to the left 8 units. So 1, 2, 3, 4, 5, 6, 7, and then finally 8 to end up at 1. So 9 plus negative 8 equals 1. And again, you could just think about this. Let's say I had $9 in my wallet. And let's say I owe my brother $8. Well, what do I have total? Well, I take the $9 that I have and I add it to the debt that I have of $8. Well, if I took the 9 and I paid off the debt of $8, I'd only have 1 left. Okay, let's look at one with more than 2 integers. So we have 7 plus negative 6 plus 4 plus negative 2. So we just start out at the leftmost number. So we're going to start out at 7. And then I'm adding negative 6. So I'm just going to the left 6 units. So let's change our pen. So we're going to go 1, 2, 3, 4, 5, and then 6. So that's going to put me at 1. Now I'm going to add 4. So I'm going to add 4. So I'm going to go 1, 2, 3, 4 units to the right. Okay, so that's going to put me at 5. Now finally, I'm going to add a negative 2. So if I'm adding a negative 2, I'm just moving to the left 2 units. So let me change colors to purple. And I'm starting here, and I'm going to go 1, 2 units to the left to end up at 3. So this equals 3. Okay, so now we have add without a number line. We start out with negative 3 plus negative 8. So when we add integers and they have the same sign, it's very, very simple. All you do is add the absolute values of the numbers, and you just attach the common sign. So I'm just going to pretend both of these numbers are positive. So I would think about 3 plus 8. What is 3 plus 8? That's 11. Then I just use the common sign. The common sign is negative, so I just slap that on. So negative 3 plus negative 8 is negative 11. And if you ever get lost, just think about your bank account. You have a balance of negative $3. You go out and you spend 8 more. What's your balance now? Well, you know you're going to have negative $11 because you had a debt of 3 and you spent 8 more. 3 plus 8 is 11, and we're talking about things that are debts, so we have a negative value. What about negative 7 plus negative 2? Again, the same thing. We're adding 2 negatives, so the result will be negative. And then I just think about the absolute values of the numbers. 7 plus 2 is 9, so negative 7 plus negative 2 is just negative 9. All right, now let's look at some where we have mixed signs involved. And this is just a little bit more tedious, but it's not very hard. So 14 plus negative 23. Okay, so the first thing I want to do is think about the absolute value of each number. So the absolute value of 14 is 14. The absolute value of negative 23 is 23. Now, I want to use the sign of the number that has the larger absolute value. In this case, that is going to be negative 23. So we're using its sign. So the result will be negative. Now, what we want to do is we want to subtract the larger number minus the smaller number. So we would do 23 minus 14. So I would borrow here. 13 minus 4 is 9. So I would end up with a negative 9 as my answer. And again, you can use money for this. If I have $14 in my bank account and I go out and I spend 23, well, I spent $9 more than I had. So what happens is I now have a bank balance that says negative $9. What about negative 5 plus 8? Well, again, what's the absolute value of each number? So the absolute value of negative 5 is 5. The absolute value of 8 is 8. So 8 has the larger absolute value, so we use its sign. Its sign is positive. So you can either put a plus out there to remind yourself the answer is positive, or you can just leave it blank, whatever makes you feel more comfortable. So now I just want to subtract. And you could say, okay, I'm going to subtract the larger number minus the smaller number, or you can say, hey, I'm taking away the smaller number from the larger, whatever you want to say. So we're basically going to do 8 minus 5, 8 minus 5, and we know that's 3, right? We know that's 3. And again, thinking about this using money, I want to just drill this into your head so if you get stuck on a test, you can kind of visualize what's going on. I owe $5 to my dad. I get $8 in from, let's say, mowing a lawn. Well, now, if I think about those two things, I have $8 and I have a debt of 5. I could take the 8, I could pay off my debt of 5, and I'd still have $3 left over. So negative 5 plus 8 is going to give me a positive 3. All right, let's look at adding more than two integers. And again, the easy way to do this is just add the numbers with a common sign, and then you'll do your mixed addition last. So we have 3 plus negative 6 plus 1 plus negative 4. Let's reorder this. 3 plus 1 plus negative 6 plus negative 4. I just like to write my numbers with common signs next to each other. It makes it easier for me to do the addition mentally. So 3 plus 1 is 4, plus negative 6 plus negative 4. Again, use your common sign in the answer, so it's negative. And then just add the absolute value. So 6 plus 4 is 10. So we get negative 10 there. And now we're just adding. We have 4 plus negative 10. So kind of thinking about this, I have $4 in my wallet and I spend 10. I'm going to owe $6, right? Because I spent $6 more than I had. But again, kind of thinking about this the traditional way, take the absolute value of each number. The absolute value of 4 is 4. The absolute value of negative 10 is 10. And we know that the absolute value of negative 10 is larger, right? It's 10. So we use its sign in the answer. So its sign is negative, and then we would subtract. We would take the smaller number away from the larger when we think about the numbers in absolute value. So we would do 10 minus 4, and that gives me 6, right? So bring that up here. And of course, we end up with negative 6 as our answer. All right, now we have negative 30 plus 18 plus negative 24. So let's add negative 30 and negative 24 first. So to do that, the sign is going to be negative, right? That's the common sign. And we think about just 30 plus 24, right? Thinking about the numbers in terms of their absolute values. So 0 plus 4 is 4, 3 plus 2 is 5. So this would be negative 54. And now I want to add 18 to that. Okay, so again, think about these numbers in terms of their absolute value. So this would be 54, this would be 18. Now, 54 is the larger number, so we would use the sign from negative 54 in our answer. So it's going to be negative. Now I want to subtract 54 minus 18. So 54 minus 18, 14 minus 8 is 6, 4 minus 1 is 3. So this is going to give me 36 here. And when I bring it up here and I attach the negative to it, I end up with a negative 36 as a result. All right, what if we have negative 20 plus 15 plus negative 32? So again, I'm going to add these two negatives first. And that's kind of easy to do in my head. So I have negative 20 and negative 32. I know that's negative. 20 plus 32 is 52. And I kind of just mentally did a vertical addition. But just for the sake of completeness, let's go ahead and do that. 0 plus 2 is 2. 2 plus 3 is 5. So this is negative 52. Okay, now we're adding to that 15. And again, think about these numbers in terms of their absolute values. So negative 52, the absolute value of that is 52. And the absolute value of 15 is 15. So the first thing is we know the sign is going to be negative, right? Because the absolute value of negative 52 is greater than the absolute value of 15. And then we're going to subtract 15 away from 52. So we're basically going to do this problem here. So 52 minus 15. And let me just kind of scroll over a little bit. So this would be 4. 12 minus 5 is 7. 4 minus 1 is 3. So you get 37 there. So this equals 37. So the answer is going to be negative 37. Okay, let's look at one final problem. We have 17 plus negative 28 plus negative 34 plus 42. So again, I'm going to think about adding the positive numbers together first, then the negative numbers together, and then we'll do a mixed addition. So what is 17 plus 42? So let's write this as 17 plus 42 plus negative 28 plus negative 34. And again, what is 17 plus 42? 42 plus 17. 2 plus 7 is 9. 4 plus 1 is 5. So we're going to write this as 59. 59 plus negative 28 plus negative 34. Next, let's think about this. What is negative 28 plus negative 34? Well, again, if we're adding two numbers with the same sign, we use that common sign in the answer. So we'd have a negative, and then we just add the absolute value. So 28 plus 34. So 28 plus 34. 8 plus 4 is 12. 1 plus 2 is 3. 3 plus 3 is 6. So that is 62. Slap that negative on it, you get negative 62. All right, so now we're left with 59 plus negative 62. And again, I have a balance of $59 in my checking account, and I spend 62. Well, we all know we're now going to have a balance of negative $3 in our checking account. Right? You should be able to do that without going through the operation because I spent $3 more than I had. But again, to kind of do this, the absolute value of 59 is 59. The absolute value of negative 62 is 62. And so, again, I use the sign of the number with the larger absolute value. So the sign of this answer is going to be negative. And then we're subtracting absolute values. So we're doing 62, the larger number, minus 59, the smaller. So this will be 5. 12 minus 9 is 3. And 5 minus 5 is 0. So again, drag this up here. And again, you get negative 3. Hello and welcome to Pre-Algebra Test Section 1 on adding integers. Okay, we want to add each using a number line, and we're going to start out with negative 5 plus negative 7. So what we're going to do here is we're going to start out at the leftmost number of the addition problem on the number line. So here's negative 5. Let me highlight that guy. So that's negative 5. Now I'm adding negative 7. So what I'm doing is, if I'm adding a negative 7, that's just telling me that I'm moving to the left 7 units. So I'm going to go 1, 2, 3, 4, 5, 6, and then 7. So I end up right here, and that's going to put me at negative 12. So negative 5 plus negative 7 is negative 12. Okay, what about negative 6 plus negative 8? Again, I'm going to start out at the leftmost number. So I'm going to start out here at negative 6, and then I'm adding a negative 8. So I'm going to move to the left 8 units. And let me just highlight this real quick. I'm going to move to the left 8 units. So 1, 2, 3, 4, 5, 6, 7, and then finally 8. So we end up right here, and that's going to put us at negative 14. Okay, negative 14. Okay, now let's add negative 2 and 4. So to add negative 2 and 4, we basically start out at the leftmost number. Again, we're going to start out at negative 2. So that's right here. And I'll go ahead and highlight that. And then if I add 4, I'm just moving to the right 4 units. When you're adding a positive, you're moving to the right by that number of units. If you're adding a negative, you're moving to the left, you could say, by the absolute value of that number's units. But basically, if I was adding negative 4, I would just go to the left 4 units. Or if I was adding negative 12, I go to the left 12 units. I'm adding 4 here, so I'm moving to the right 4 units. So 1, 2, 3, finally 4, and I end up at 2. Okay, so I end up at 2. So negative 2 plus 4 is 2. Hello and welcome to Pre-Algebra Test Section 2 on adding integers. All right, so we want to add each using a number line, and we're going to start out with negative 7 plus 14 plus negative 11 plus 4. So when we add a positive number, So let's say I'm adding 3. I'm moving to the right by that number of units, so I'd move to the right 3 units. If I add a negative number, I'm going to move to the left by the absolute value of that number's units. So if I'm adding, let's say, -6, the absolute value of -6 is 6, so I'd move to the left 6 units. So if I look at this, I start out at the leftmost number. So I start out at -7. So that guy's going to be right here. And let's just highlight that to be clear. And then I'm adding 14. So that means I'm moving 14 units to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14. So that puts me here at 7. Okay, that puts me at 7. Let me just highlight that guy. So now I want to add a -11. So that means I'm going to move to the left 11 units. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then lastly 11. So that puts me at -4. So right here. The last thing I'm going to do is I'm going to add 4. So that's a movement to the right 4 units. So let's do that in purple. So starting here, I'm going to go 1, 2, 3, and then 4. And so I end up at 0. Okay, that's where I end up. So here's my answer for the problem. So -7 plus 14 plus -11 plus 4 gives me 0. And you can kind of look at this and mentally see why. If I add -7 and -11, again, adding negatives, you keep the sign the same, so it would be negative, and then you just do the absolute values. So 7 plus 11 is 18. So I'd have -18. And plus, if I think about 14 plus 4, that's also 18. If you add a number and its opposite, you always get 0. So -18 plus 18 is 0. So that's why we ended up at 0 here. Okay, for the next problem, we have -5 plus 2 plus -6 plus 1 plus -3. So we're going to start out at -5 on the number line. So that's right here. Let's highlight that guy. And we're going to add 2. So that means we're just going to move 2 units to the right. So I'm just going to go 1, 2 units to the right. That puts me at -3. Now I'm going to add -6. So that means I'm moving 6 units to the left. So let's do that in a purple. So I'm going to go 1, 2, 3, 4, 5, and then 6 units to the left. Let's highlight that guy. So now I'm at -9. And I want to add 1. So that means I'm just going to move 1 unit to the right. So we'll do that in kind of a dark blue. So 1 unit to the right. And that's going to put me at -8. So let's highlight that. And then we have one more movement to do. We're adding a -3. So if we're adding a -3, that means we're moving 3 units to the left. So we can do that in a maroon. So we'll start right here. We're going 1, 2, 3 units to the left. And we end up at -11. And let me kind of highlight our answer with kind of a different color. So -11 is our result. -11. And again, just kind of add this without the number line. If I look at the numbers that are the same, meaning they have the same sign, -5 plus -6 would be -11. Right? You keep the common sign, which is negative, then you just do 5 plus 6, that's 11. So you combine the negative and the 11, you get -11. Then you add a -3 to that. So you get -14. Right? If you add -11 plus a -3, the sign would be negative, and you just do 11 plus 3, that's 14. Okay, so now having -14, I'm thinking about our positive values here. I have 2 plus 1, that's 3. So I'm adding 3. So what is -14 plus 3? Well, again, use the sign of the number with the larger absolute value. So we're using the sign from -14. And then we want to subtract absolute values, but we want to subtract the smaller absolute value from the larger. So we would do 14 minus 3, and that's 11. So we end up with -11. Again, exactly what we got here using the number line. Hello and welcome to Pre-Algebra Test Section 3 on adding integers. All right, so we want to just find each sum, and we're going to start out with -15 plus -30. All right, so when we add integers and they have a common sign, we just keep the common sign. So in this case, we're adding 2 negatives. So the common sign is negative, so we're just going to keep that sign. and then you just add the absolute values of the numbers. So you think about this just as 15 plus 30. Most of you know that's 45, but just for the sake of being complete, let's do a vertical addition. 0 plus 5 is 5. 3 plus 1 is 4. So we have 45 there, and you just stick it up there next to the negative, and we have negative 45 as our answer. What about negative 2 plus negative 8 plus negative 17? Well, in this problem, everything is a negative, so the answer is going to be negative, and then we can just add absolute values. So you think about 2 plus 8 plus 17. Well, 2 plus 8, you can do that in your head, that's 10, and then 10 plus 17, 10 plus 17, well, let's do this in vertical addition format. 7 plus 0 is 7. 1 plus 1 is 2. So we get 27. All right, so I'm going to write that next to that negative. And so our answer here is going to be negative 27. Okay, then what about negative 4 plus negative 7 plus negative 1? Well, again, everything here is a negative, so my answer is negative. And then I can just add absolute values. 4 plus 7 would be 11. And then add one more, that would be 12. Stick that next to that negative, and you end up with negative 12. Okay, for the final problem, we have negative 12 plus negative 22 plus negative 13 plus negative 40. So we know that the result here is going to be negative, right? We have all negative numbers involved. I just need to go through and add absolute values. So let's do a vertical addition with 12, 22, 13, and 40. And again, all I did was just take the absolute value of each number. All right, so 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 0 is still 7. 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 4 is 8. So you'd end up with 87 there. Again, you're going to stick that next to the negative because we already figured out this answer would be negative. And we're done. Our answer here is negative 87. Hello and welcome to Pre-Algebra Test Section 4 on adding integers. All right, we just want to find each sum. Okay, so we're going to start out with 6 plus negative 7. So in the lesson I taught you, basically there's two steps to this. The first step is just figuring out what the sign is, or you can kind of think about these steps. You can switch what's first and what's second. It doesn't really matter. But the first step is figure out what the sign is. And the way you do that is you think about which number has the larger absolute value. So if I look at 6, the absolute value is 6. If I look at negative 7, the absolute value is 7. Negative 7 has a larger absolute value, and so we will use its sign in the answer. So we will put a negative there, and then we'll figure out the number part. We know the sign is negative. What's the number part? Well, to do that, you subtract absolute values. So you think about, we already have the absolute values there. You'd subtract the smaller from the larger. So you would just do 7 minus 6, and that would give you 1. Okay, that would give you 1. So the answer here is negative 1. And logically, if you think about this, let's say you have $6 in your bank account and you spend 7. You're going to end up with a balance of negative $1, right? Because you spent $1 more than you had. What about negative 4 plus 3? Again, think about the sign of the answer. So the absolute value of negative 4 is 4. The absolute value of 3 is 3. The absolute value of negative 4 is larger, so we're going to use its sign in the answer, right? So the answer will be negative. And now you just subtract absolute values. You're just going to do 4 minus 3, right? 4 minus 3 is 1. So the answer here is negative 1. What about 12 plus negative 1? Again, what's the absolute value of each number? So this one would be 12. This one would be 1. So 12 has a larger absolute value, so the sign for the answer will be positive. So you can put a positive out here to remind yourself you already did it, or you can just leave it blank. It doesn't really matter. We'll just leave that out there. And then we're going to subtract absolute values. So we'll do 12 minus 1, and that gives us 11. Right? 12 minus 1 equals 11. So our answer here is going to be positive 11. And again, just think about this as, okay, I have $12 in my wallet, and I take 1 away. Now I'm going to have 11. Or I have $12 in my wallet, and I owe somebody $1 somewhere. Right? It's the same thing, because you have to take that dollar away from me to pay that debt off. So really, if I add those two amounts together, the amount I have plus my debt, this is going to be my total, right? I'm really worth $11 right now. I have 12 on me. I got a debt of 1. My total amount that I'm worth is $11. What about 15 plus negative 9? Again, what's the absolute value for each? So the absolute value of 15 is 15. The absolute value of negative 9 is 9. So we're going to use the sign of the number with the larger absolute value, and that's 15. Right? So this guy's going to be positive. Then we're going to subtract. We're going to do 15 minus 9. 15 minus 9 is 6. So we'll end up with positive 6 as our answer. Again, not to beat a dead horse, but you have $15 in your wallet and you owe somebody $9. If you were to take $9 out and pay that debt off, you would only have 6. Right? That's what this is saying. 15 plus a negative 9 is 6. What about 34 plus negative 28? Well, what's the absolute value of 34? That's 34. The absolute value of negative 28 is 28. And so this answer is going to be positive because 34 has a larger absolute value. And then we just subtract. What is 34 minus 28? We'll borrow here. 14 minus 8 is 6. So we end up with positive 6 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on adding integers. All right, so we just want to find each sum. We're going to start out with negative 25 plus 17 plus negative 27 plus 60. So when you run across problems like this, you want to reorder everything and put your negatives next to each other and put your positives next to each other. You don't have to do that, but typically it's going to help you because in a problem like this, most people are going to add their negatives together and their positives together separately, and then they'll do kind of the mixed addition last. So if I add negative 25 and negative 27, it's easy to do. I know the sign is negative. And then I just add the absolute values. So I'll do 25 plus 27. 5 plus 7 is 12. 1 plus 2 is 3, plus 2 is 5. So I'll end up with a negative 52. Now if I want to add 17 plus 60, so 17 plus 60, 7 plus 0 is 7, 1 plus 6 is 7, I'd get 77. So now we have an addition where we have different signs. Remember, we use the sign of the number that has the larger absolute value. So the absolute value of negative 52 is 52. The absolute value of 77 is 77. So the absolute value of 77 is larger, right, than the absolute value of negative 52. So the sign of the answer will be positive. And now we just want to subtract, right? We would do 77, which is the larger absolute value, minus 52, which is the smaller absolute value. 7 minus 2 is 5. 7 minus 5 is 2. So you'd end up with positive 25 as your answer. Okay, let's look at another one. We have negative 40 plus 15 plus negative 22 plus negative 18 plus 55. All right, so again, I'm just going to reorder everything to where all the negatives are next to each other and all the positives are next to each other. And again, as you move forward, you're probably not going to do that. You can just kind of add this stuff in your head. But just for the sake of completeness, let's reorder everything. So negative 40 plus negative 22 plus negative 18, then plus 15, then plus 55. Okay, so let's add all our negatives together first. So I know the result will be negative, and then I can just add absolute values. So I can think about 40, 22, and 18. And what's the sum here? 0 plus 2 is 2. 2 plus 8 is 10. 1 plus 4 is 5. 5 plus 2 is 7. 7 plus 1 is 8. So I'd end up with negative 80. And now I just want to add the positive numbers. 15 plus 55. Okay, a lot of you at this point know that's 70. But for the sake of completeness, again, let's do it using a vertical addition. 5 plus 5 is 10. 1 plus 5 is 6. 6 plus 1 is 7. So again, this is 70. And now we have one final step to do. We have a negative and a positive. When this happens, again, we use the sign of the number that has the larger absolute value. So the absolute value of negative 80 is 80. The absolute value of 70 is 70. So negative 80 has a larger absolute value, so we're going to use its sign in the answer, right? So the answer is negative. Now we just subtract absolute values. We take the larger absolute value, which is 80. We subtract away the smaller, which is 70. 80 minus 70 is 10. So you slap that up there next to the negative, and we end up with negative 10 as our answer. Okay, so I have kind of a big problem here, and I had to shrink the font down actually just to make it fit on the screen, so hopefully it's not cut off. So we have 4 plus negative 7 plus 3 plus negative 8 plus 2 plus negative 9 plus 1 plus negative 10. So let's put all the positive numbers together. So 4 plus 3 plus 2 plus 1. Let's put all the negatives together. -7 plus -8 plus -9 plus -10. Okay, so 4 plus 3 is 7, 7 plus 2 is 9, 9 plus 1 is 10. The negatives, again, the answer will be negative. And just go through and add. Think about each one as if they were a positive number, right? We're just working with absolute values. So what's 7 plus 8? That's 15. Then 15 plus 9 is 24. And again, for the sake of completeness, let me do this using a vertical addition. 5 plus 9 is 14. Carry the 1. 1 plus 1 is 2. So that's 24. And then lastly, you're adding 10. So that would be 34. So we ended up with negative 34 here. And again, for the sake of completeness, let me just do that using a vertical addition. So 24 plus 10. 4 plus 0 is 4. 2 plus 1 is 3. Okay, so when I slap that next to the negative, again, I end up with negative 34. So now we've got this problem down to just two numbers, 10 and negative 34. So when you think about it, the absolute value of 10 is 10. The absolute value of negative 34 is 34. So we're going to use a negative in our answer, right? Because negative 34 has a larger absolute value. And then we're just going to subtract the larger absolute value minus the smaller absolute value. So 34 minus 10. 4 minus 0 is 4. 3 minus 1 is 2. So we end up with 24 there. But again, remember, we have to attach that negative to it. And we end up with negative 24 as our answer. Hello and welcome to Pre-Algebra Practice Set number 20. And in this video, we're going to look at some additional practice problems for our lesson on subtracting integers. Okay, we just want to perform each subtraction. So we're going to begin today with negative 6 minus 3. And what I told you in the lesson was you're going to take your subtraction problems and change them into related addition problems. So negative 6 stays the same. You change your subtraction to addition, and then you change your number that's being subtracted away, which in this case is 3, into its opposite. So the opposite of 3 is negative 3. So if I'm subtracting away 3, it's the same as adding negative 3. So we've changed this problem to negative 6 plus negative 3. That's pretty easy to do. We just keep the sign that's common to both. So the answer would be negative. And then we just add our absolute values, right? So we're going to add 6 plus 3, and that's 9. So our answer here is negative 9. What about negative 8 minus 2? Well, again, we're going to change this to a related addition problem. Keep this negative 8 the same. Okay, your leftmost number stays the same. Change your subtraction to addition, and change the number being subtracted away, which in this case is 2, into its opposite. So the opposite of 2 is negative 2. And so now we have an addition problem, negative 8 plus negative 2. So the signs are the same, so the answer will have a negative sign. And we just add the absolute values. So 8 plus 2 is 10. So our answer here will be negative 10. What about negative 7 minus a negative 5? So as I taught you in the lesson, when you see minus a negative, it's plus a positive. Okay? Minus a negative is plus a positive. So negative 7 will remain unchanged. Change your subtraction to addition and change the number being subtracted away. In this case, it's a negative 5 into its opposite. The opposite of negative 5 is positive 5. Again, subtracting away a negative 5 is the same as adding a positive 5. Subtract away a negative, you're adding a positive. Okay, so negative 7 plus 5. Use the sign from the number with the larger absolute value. In this case, that's going to be negative 7. Right? So the sign will be negative. The absolute value of negative 7 is 7. The absolute value of 5 is 5. So now we subtract absolute values. Right? We take the larger, subtract away the smaller. So you'd have 7 minus 5, and that's 2. You attach that to that negative, and your answer here is negative 2. Okay, what about negative 4 minus 3? Again, leave this leftmost number unchanged, so negative 4. Change your subtraction to addition. Change your number 3 that's being subtracted away into its opposite. The opposite of 3 is negative 3. So now we have negative 4 plus negative 3. Again, keep the common sign in the answer, so the answer is negative. And just add the absolute values of the numbers. So 4 plus 3 is 7. So this ends up being negative 7. What about 9 minus 13? Again, keep this leftmost number unchanged. Change your subtraction to addition. And change 13, the number that's being subtracted away, into its opposite. So now we have 9 plus negative 13. So we use the sign from the number with the larger absolute value. The absolute value of negative 13 is 13. The absolute value of 9 is 9. So negative 13 has a larger absolute value, so the answer will be negative. And now we just subtract the absolute values, right? We take 13, which is the larger, and we subtract away 9, which is the smaller. 13 minus 9 is 4, so our answer here will just be negative 4. Okay, when we subtract integers and there's more than 2 involved, you basically use the same procedure. When you're subtracting away a number, you're just going to change that subtraction to addition of the opposite. So if we have negative 8 minus a negative 1 minus 5, negative 8 stays the same. But then I'm subtracting away a negative 1. Change that to addition of the opposite. So I'm adding a positive 1. I'm subtracting away 5. Change that to addition of the opposite. So plus a negative 5. So now I have 3 numbers involved. 2 of them have the same sign. Let's add those first. So negative 8 plus negative 5 plus 1. What's negative 8 plus negative 5? Use the common sign in the answer. So that would be negative. And then just do the absolute values. So 8 plus 5 is 13. So this would be negative 13 and then plus 1. All right, so to solve this problem, again, use the sign from the number with the larger absolute value. The absolute value of negative 13 is 13. The absolute value of 1 is 1. So our answer will be negative. And then just subtract the absolute values, right? You do the larger minus the smaller. So you're going to do 13 minus 1, and that's 12. So we end up with negative 12 as our answer. Okay, what about negative 3 minus 7 minus negative 5 minus 16? All right, so the first number, or the leftmost number, stays the same. So negative 3. I'm subtracting away 7, so I'm going to change that to addition of the opposite. So plus a negative 7. I'm subtracting away a negative 5. So I'm going to add the opposite of negative 5, which is positive 5. Again, when you see minus a negative, you should be thinking plus a positive. Then I'm subtracting away 16, so I'm going to change that to plus a negative 16. So I have 3 numbers here with a negative sign, and so I'm going to add those 3 together first. So I know the result will be negative, and I'm just going to add absolute values. So 3 plus 7 would be 10, and then 10 plus 16, 0 plus 6 is 6, 1 plus 1 is 2. So we'd end up with negative 26, and then plus 5. Okay, so for this one, again, we use the sign from the number with the larger absolute value. So in this case, that's going to be negative 26, right? The absolute value of negative 26 is 26. The absolute value of 5 is 5. So our sign will be negative. Okay, now we want to subtract absolute values. We do the larger minus the smaller. So we're going to do 26 minus 5. 6 minus 5 is 1. Bring down the 2. So we're going to end up with negative 21. Okay, negative 21 as our answer. All right, for the final problem, we have negative 5 minus 12 minus 6 minus a negative 10. All right, so starting out all the way on the left here, this negative 5 is going to remain unchanged. Then I'm subtracting away 12, so that's the same thing as adding a negative 12. I'm subtracting away 6. That's the same thing as adding a negative 6. And then I'm subtracting away a negative 10. That's the same thing as adding a positive 10. Again, subtract away a negative, add a positive. All right, so again, we have the same scenario where 3 of the numbers are negatives. Let's just add those 3 together first. We know the answer will be negative. So just think about the absolute values here. 5 plus 12 is 17, and then 17 plus 6, 7 plus 6 is 13. Carry the 1, 1 plus 1 is 2. So the result is going to be negative 23, then plus 10. Okay. Again, to solve this, use the sign from the number with the larger absolute value. In this case, that's going to be negative 23, right? The answer is going to be negative. The absolute value of negative 23 is 23. The absolute value of 10 is 10. So now we subtract the absolute values. We'll do 23, which is the larger, minus 10, which is the smaller. So 23 minus 10, 3 minus 0 is 3, 2 minus 1 is 1, gives us 13. So we end up with negative 13 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on subtracting integers. All right, we just want to perform each subtraction, and we're going to start out with 6 minus 8. So what I told you in the lesson was, essentially we're going to transform our subtraction problems into a related addition problem. So the way you do that is you keep the leftmost number unchanged, you change your subtraction to addition, and then you change your number that's being subtracted away, which in this case is 8, into its opposite. So the opposite of 8 is negative 8. So subtracting away positive 8 is the same thing as adding negative 8. So now that we have a related addition problem, we can just perform this with our rules for adding integers. So if we have 6 plus negative 8, the result will be negative, right? Because negative 8 has a larger absolute value. And then we would just subtract 8 minus 6. The absolute value of negative 8 is 8. We would take away the absolute value of 6, which is 6. 8 minus 6 is 2. So we end up with negative 2 as our answer. What about 11 minus 17? Well, again, I'm going to leave the first number here, or the leftmost number, unchanged. I'm going to change my subtraction to addition, and then I'm going to change 17 into its opposite. So again, subtracting away 17 is the same as adding a negative 17. Now, if I look at these two numbers, I can see that the absolute value of negative 17 is larger, so the sign is going to be negative. And then I just want to subtract absolute values. So the absolute value of negative 17 is 17. The absolute value of 11 is 11. I would do 17 minus 11. That's 6. And so I'd end up with negative 6 as my answer. Okay, what about negative 15 minus 9? Well, again, this leftmost number is going to stay unchanged. And then I'm subtracting away 9, so that's the same thing as adding a negative 9. So if I have negative 15 plus a negative 9, the sign here is the same. In each case, I have a negative. So the answer will be negative. And then I just add absolute values. So I just pretend both those numbers are positive. I would say, well, what is 15 plus 9? 5 plus 9 is 14. 1 plus 1 is 2. So I drag this over here, and I end up with negative 24 as my answer. What about negative 12 minus 22? Well, again, keep this leftmost number the same. Change your subtraction to addition. Change 22, the number that you're subtracting away, into its opposite. So subtracting away 22, again, is the same as adding negative 22. All right, so to do this, we have the same sign. So the answer will be negative. And then we just want to add absolute values. So we do 12 plus 22. 2 plus 2 is 4. 1 plus 2 is 3. So we drag this up here, and we'd end up with negative 34 as our answer. Okay, for the last problem, we have negative 14 minus 115. So again, this leftmost part here stays the same. Change your subtraction to addition, and change this 115 here, the number that's being subtracted away, into its opposite. So it'll become negative 115. And now we just want to add. Again, the sign will be negative because we have our two numbers that are being added as negative. And then we just add absolute values. So what is 115 plus 14? 5 plus 4 is 9. 1 plus 1 is 2. Bring down the 1. You can kind of send this over here and say we have a result of negative 129. Hello and welcome to Pre-Algebra Test Section 2 on subtracting integers. Okay, so we want to perform each subtraction, and we're going to start out with negative 7 minus 8. So what we're going to do here is we're going to leave the leftmost number, which in this case is negative 7, unchanged. I'm going to change my subtraction operation to addition, and then I'm going to change this number 8, the number that's being subtracted away, into its opposite. So I've converted this to a related addition problem. Negative 7 minus 8 is the same as negative 7 plus negative 8. Subtracting away 8 is the same as adding a negative 8. So now we can just add these two integers. They have the same sign, so the answer will be negative, right? We use the common sign in the answer. Now we just add absolute values. What is 7 plus 8? Well, that's 15. So our answer here will just be negative 15. What about a negative 4 minus a negative 2? Now I taught you in the lesson when you see minus a negative, you think plus a positive. So negative 4 will stay the same. Change your subtraction to addition. Change the number being subtracted away. In this case, it's a negative 2 into its opposite. The opposite of negative 2 is positive 2. Again, if you see minus a negative, think plus a positive. So what is negative 4 plus 2? So when we have different signs, again, we think about the absolute value of each. The absolute value of negative 4 is 4. The absolute value of 2 is 2. So negative 4 has a larger absolute value So we use its sign in the answer. So the answer there is negative. Now we just subtract 4 minus 2, right? We take the larger absolute value, subtract away the smaller. So 4 minus 2 is 2. Slap that negative on there, and we end up with negative 2 as our answer. Okay, what about negative 1 minus 99? So again, I keep the leftmost part unchanged. So negative 1 is unchanged. Change the subtraction to addition, and then change 99, the number being subtracted away, into its opposite. So what do we do now? Well, we have a common sign. We have a negative here and here, so the answer will be negative. And then I just add absolute values. What is 1 plus 99? Well, that's 100. So attach that with the negative, and you get negative 100 as your answer. What if we look at negative 70 minus a negative 12? Again, if you think about minus a negative, you should be saying plus a positive. So the negative 70, the leftmost part, stays the same. The minus sign becomes a plus, and then the opposite of negative 12 is positive 12. Again, minus a negative is plus a positive. Okay, so if we add these two numbers together, the sign will be from the number with the larger absolute value. In this case, the sign will be from negative 70, right? The absolute value of negative 70 is 70. The absolute value of 12 is 12. So our sign will be negative. Now we just subtract absolute values, right? We'll do 70 minus 12. We do the larger minus the smaller. So 70 minus 12. 10 minus 2 is 8. 6 minus 1 is 5. Drag this guy up here, and we end up with negative 58 as our answer. What about negative 18 minus a negative 13? Again, we have a scenario where we have minus a negative, so we should be thinking about plus a positive. So this leftmost part here stays unchanged. Change the subtraction to addition, and change the negative 13 to its opposite. The opposite of negative 13 is 13. Okay, so we use the sign from the number with the larger absolute value, and the absolute value of negative 18 is 18. The absolute value of 13 is 13. So we'll use the sign from negative 18. So the answer will be negative. And now we just subtract absolute values. So we'll do the larger, which is 18, minus the smaller, which is 13. 18 minus 13 is 5. So put that next to the negative, and our answer here is negative 5. Hello, and welcome to Pre-Algebra Test Section 3 on subtracting integers. All right, we just want to perform each subtraction. And essentially what we're doing here is every time we're subtracting away a number, we're changing it into addition of the opposite. So for example, in this problem, we have 3 minus 8 minus 6 minus 17. So the first number, the 3, is going to stay the same. And then I'm subtracting away 8, so I'm going to change that to adding negative 8. Okay, if I'm subtracting away 8, it's the same as adding the opposite of 8, which is negative 8. Subtracting away 6, I'm going to change that to plus negative 6. Continuing, I'm subtracting away 17, so I'm going to change that to plus negative 17. Okay, so 3 of these numbers have the same sign. So let's add those together first. So negative 8 plus negative 6 plus negative 17. We know the result would be negative, and then we can just add absolute values. So 8 plus 6 is 14, and then 14 plus 17, 4 plus 7 is 11. 1 plus 1 is 2, plus 1 is 3. So this would be negative 31. And so now we just have 3 plus negative 31. So we use the sign from the number with the larger absolute value. The absolute value of negative 31 is 31. The absolute value of 3 is 3. So we're going to use a negative sign, right? Because negative 31 has a larger absolute value. So the answer will be negative. And then we're just going to subtract absolute values. So we would do 31, which is the larger, minus 3, which is the smaller. 11 minus 3 is 8, and then bring down the 2. So we'd end up with a negative 28 as our answer. Okay, what about 5 minus 3 minus 7 minus 11? This first number 5 will stay unchanged. Then I'm subtracting away 3, so I'm going to put plus negative 3. I'm subtracting away 7, so I'm going to put plus negative 7. I'm subtracting away 11, so I'm going to put plus negative 11. So just like we had in the last problem, 3 of these numbers have the same sign, so let's add those together first. So we know the result will be negative, right, because that's the common sign, and then we just add absolute values. 3 plus 7 is 10, then plus 11 is 21. So we'd end up with negative 21 here. And now we have 5 plus negative 21. Again, to do that, think about the absolute value of each number. The absolute value of 5 is 5. The absolute value of negative 21 is 21. So we use the sign from the number that has the larger absolute value. So we're going to use the sign from negative 21. So our answer here is going to be negative. And then we just want to subtract absolute values. So we're going to do the larger, which is 21, minus the smaller, which is 5. 11 minus 5 is 6. Bring down the 1, and we end up with negative 16 as our answer. All right, for the final problem, we have negative 7 minus a negative 9 minus 4 minus 9. So negative 7 stays the same. If I'm subtracting away a negative, I'm adding a positive. Right? Think about changing the subtraction to addition and then changing what's being subtracted away. In this case, that's negative 9 to its opposite. The opposite of negative 9 is positive 9. Subtract away 4, that's the same as adding negative 4. Subtract away 9, that's the same as adding negative 9. So we have negative 7, negative 4, and negative 9 that are all negative. Well, one thing I can do to make this problem easier is I can notice that 9 and negative 9 are opposites. When opposites are added, the result is 0. So if I want to make this problem super easy, just reorder this addition and say, okay, I'm going to put negative 7 plus negative 4 plus 9 plus negative 9. Add these two parts together first, and the result is 0. So I'd have negative 7 plus negative 4, and I could write plus 0 if I want to, but you don't have to because adding 0 doesn't change anything. So I just have negative 7 plus negative 4. So I use the common sign in the answer, that's negative, and then I just add the absolute values. So 7 plus 4 is 11, so I end up with negative 11 as my answer. Hello and welcome to Pre-Algebra Test Section 4 on subtracting integers. Okay, we just want to perform each subtraction. So we're going to start out with negative 15 minus a negative 25 minus 17 minus a negative 8 minus 4. So what we're going to do is we're going to change each subtraction operation into a related addition operation. And so this negative 15 will stay unchanged. And if I'm subtracting away a negative 25, that's the same as adding a positive 25. If I'm subtracting away 17, that's the same as adding a negative 17. If I'm subtracting away a negative 8, that's the same as adding a positive 8. If I'm subtracting away a 4, that's the same as adding a negative 4. So essentially all I did was I changed the subtraction to addition, and I changed what was being subtracted away to its opposite. The opposite of negative 25 is 25. The opposite of 17 is negative 17. The opposite of negative 8 is 8. The opposite of 4 is negative 4. That's all I did. Okay, so now what I want to do is let's rewrite this as negative 15 plus negative 17 plus negative 4 plus 25 plus 8. So I put my numbers with common signs next to each other. So these three numbers are negative, these two numbers are positive. Let's add our negatives first. So the sign will be negative, and then you can just add the absolute values. So let me scroll down, and we'll just do that using vertical addition. So 15, 17, and 4. 5 plus 7 is 12. 12 plus 4 is 16. 1 plus 1 is 2. Plus 1 is 3. So this will be negative 36. And then over here I have 25 plus 8. So 25 plus 8. 5 plus 8 is 13. 1 plus 2 is 3. So we'll end up with 33 as our answer for that. And we have one final part here. We want to add negative 36 and 33. So when we add two numbers with different signs, we want to use the sign of the number with the larger absolute value. So negative 36 has an absolute value of 36. 33 has an absolute value of 33. So negative 36 has a larger absolute value, so we're going to use its sign in the answer. So the answer is going to be negative. Then you just subtract absolute values. You take the larger, which in this case is 36, and you subtract away the smaller, which in this case is 33. 6 minus 3 is 3. 3 minus 3 is 0. So we end up with 3. We attach that negative to it, and our answer is negative 3. Okay, for the last problem, we have negative 27 minus negative 103 minus 81 minus 54 minus a negative 13. All right, so this first number, or the leftmost number, stays unchanged. I'm subtracting away a negative 103. That's the same as adding a positive 103. Again, the subtraction becomes addition, and we change the number that's being subtracted away into its opposite. The opposite of negative 103 is 103. Same thing for this. Change the subtraction here to addition. 81 will become its opposite. The opposite of 81 is negative 81. Subtracting away 54. So we'll put plus negative 54. Subtracting away a negative 13. So we're adding a positive 13. So let's reorder this. I'm going to put negative 27 plus negative 81 plus negative 54. Again, I put my three numbers that had the same sign next to each other. You don't have to do that, but it's a little bit easier to me to do it. Then I'll put plus 103, then plus 13. Okay, so now we know that if we add negative 27, negative 81, and negative 54, the result will be negative. So now we can just focus on the absolute values. We'll do 27 plus 81 plus 54. 7 plus 1 is 8. 8 plus 4 is 12. 1 plus 2 is 3. 3 plus 8 is 11. 11 plus 5 is 16. So that would give me negative 162. Now I have 103 plus 13. So 103, 13. 3 plus 3 is 6. 0 plus 1 is 1. Bring down the 1. I have 116 there. So let's write that guy right here. So plus 116. And again, if we have an addition problem where the signs are different, we're going to use the sign from the number with the larger absolute value. So the absolute value of negative 162 is 162. The absolute value of 116 is 116. So we're going to use the sign from negative 162. All right, so the result is going to be negative. And then we just do a basic subtraction. We do the larger absolute value, which is 162, minus the smaller absolute value, which is 116. We'll borrow here. 12 minus 6 is 6. 5 minus 1 is 4. 1 minus 1 is 0. So drag that up here, and we end up with negative 46 as our answer. Hello, and welcome to Pre-Algebra Test Section 5 on subtracting integers. All right, so we just want to perform each subtraction. And what we're going to do for these problems is we're going to change the subtraction operation to addition of the opposite. So we have negative 90 minus 27 minus negative 7, minus 14, minus negative 28, minus 11. So this first number is going to stay the same. Now I'm subtracting away 27. That's the same thing as adding negative 27. I'm subtracting away negative 7. That's the same thing as adding positive 7. Subtracting away a negative is adding a positive. I'm subtracting away 14. That's the same thing as adding negative 14. Then I'm subtracting away a negative 28. That's the same thing as adding a positive 28. And then lastly, I'm subtracting away 11. That's the same thing as adding a negative 11. So let me continue that down here. Plus negative 11. And what I'm going to do now is I'm going to reorder this addition to where all my negative numbers are next to each other and all my positive numbers are next to each other. And I just like to do that for myself. It keeps me organized. So I'll have negative 90 plus negative 27 plus negative 14 plus negative 11. Now I have my two positive numbers, so plus 28 and then plus 7. And remember, because we're using addition here, addition is commutative and we can add in any order that we'd like. Okay, so let's start by adding the negative numbers. So that's these here. And we know the result's going to be negative. So we're just going to do a vertical addition with the absolute values. So 90, 27, 14, and 11. Let's add those. So 0 plus 7 is 7. 7 plus 4 is 11. 11 plus 1 is 12. 1 plus 9 is 10. 10 plus 2 is 12. 12 plus 1 is 13. 13 plus 1 is 14. So we get 142. So we'll bring that over. And remember, this will be a negative 142 because we were working with negative numbers. So then plus, next we have 28 plus 7. A lot of us can do that in our head because we watch football. We know that if a team has 28 and they score a touchdown and kick an extra point, they get another 7 points and they get 35. But we can do that using a vertical addition. 8 plus 7 is 15. 1 plus 2 is 3. Again, 35. All right. So now we have negative 142 plus 35. So we're going to use the sign from the number with the larger absolute value. And obviously that's negative 142. All right, so the sign of the answer will be negative. And then we're just going to subtract absolute values. So the absolute value of negative 142 is 142. The absolute value of 35 is 35. We subtract the bigger number, 142, minus the smaller number, 35. And so we borrow here. 12 minus 5 is 7. 3 minus 3 is 0. Bring down the 1. So we get negative 107 as our answer. Okay, let's take a look at negative 45 minus 300 minus negative 4 minus negative 2 minus 39 minus negative 73. Okay, so we're going to change this to a related addition problem. So negative 45 stays the same. And I'm subtracting away 300, so I can write that as plus negative 300. I'm subtracting away a negative 4, okay? Minus a negative is plus a positive. So subtracting away negative 4 is the same as plus positive 4. I'm subtracting away a negative 2, that's the same as plus positive 2. I'm subtracting away 39, that's the same as plus negative 39. And then lastly, I'm subtracting away a negative 73, that's the same as adding a positive 73. Okay, now going through here, let's write this as negative 45 plus negative 300 plus negative 39, then plus 4 plus 2 plus 73. And all I did was I reordered my addition to where my like signs were next to each other. So let's add the negatives here, and we know that the result will be negative. And now we can just worry about the absolute values. So I'll do that using a vertical addition. So 300, 45, and 39. 0 plus 5 is 5, plus 9 is 14. 1 plus 0 is 1, plus 4 is 5, plus 3 is 8. Bring down the 3. So you'd have negative 384. Then we have 4 plus 2 plus 73. You can pretty much do that in our head. 4 plus 2 is 6. 6 plus 73 is 79. So plus 79. Okay, so now when we add two numbers with different signs, again, we use the sign from the number with the larger absolute value. So negative 384 has an absolute value of 384. 79 has an absolute value of 79. So I'm going to use the sign from negative 384. It has a larger absolute value. So the sign of the answer will be negative. And then I just want to subtract. I want to do the larger absolute value, which is 384, minus the smaller absolute value, which is 79. So I'll borrow here. 14 minus 9 is 5. 7 minus 7 is 0. Bring down the 3. And we get 305. Drag that over here. And remember, it's negative, right? We attach the negative to it. And we end up with negative 305 as our answer. Hello and welcome to Pre-Algebra Practice Set 21. And in this video, we're going to look at some additional practice problems for our lesson on multiplying and dividing integers. So we're going to start out with some multiplication problems, and we want to just find each product. So before we actually begin, let me refresh your memory on how we perform a multiplication when there's integers. So essentially, you're going to figure out what the sign is going to be first. And to do that, you have a basic rule. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. Once you do that, you just multiply the absolute values of the numbers. Now, if I start out with something like negative 6 times negative 7, the signs are the same. I have a negative times a negative. So the signs are the same, the answer is positive. Now, I just work with the absolute values. So 6 times 7 would give me 42. So the answer here would be positive 42, or just 42. Next, I have negative 4 times 2. Now the signs here are different. I have a negative times a positive. So the answer will be negative. And now I just multiply absolute values. So I would do 4 times 2, and that's 8. So my answer here is negative 8. What about 3 times negative 8? Well, I have a positive times a negative. So the signs are different, so the answer is negative. Then I would just do 3 times 8, that's 24. So my answer here would be negative 24. Okay, for the next problem, we have 12 times negative 10. So we have a positive times a negative. Positive times negative gives me a negative. right? If the signs are different, I have a negative result. Now I just multiply the absolute values. So 12 times 10 would be 120, right? So this would give me negative 120. What about negative 1 times negative 14? Negative times negative is positive, right? If the signs are the same, okay, if the signs are the same, the answer is positive. Then you just do 1 times 14, and that's 14. Okay, what about 5 times negative 2? So we have a positive times a negative. So the signs here are different, so I'm going to get a negative, right? So 5 times 2 then would be 10, and the answer would be negative 10. Okay, then let's look at negative 18 times negative 20. So we have a negative times a negative. That's going to give us a positive. And then we would just do 18 times 20. Now, a lot of you might set up a vertical multiplication for that. But again, you can use your trick for trailing zeros. Think about 18 times 2. That's 36. And then you're going to attach one trailing zero to the end of that. So we end up with a positive 360. Okay, now let's look at some problems that involve more than two integers. So we'll start out with 3 times 6 times negative 8. So for these problems, kind of the fastest way to do it would be to think about what's my sign going to be first. Now, I gave you a little trick for that in the lesson. If the number of negative numbers you have involved is an even number, meaning it's a number that is divisible by 2, okay, you divide by 2, you get no remainder, then the result will be positive. If it's odd, okay, meaning it's not divisible by 2, you divide by 2, you get a remainder, then the answer is negative. Now in this case, this 3 times 6 times negative 8, we have one negative value. 1 is an odd number. It is an odd number. It's not divisible by 2. So our answer here will be negative. Now we can just pretend all the numbers are positive, right? We can just work with the absolute values. And 3 times 6 would be 18. And then you'd multiply 18 times 8. 18 times 8. 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. So drag that back up there. And we end up with negative 144 as our answer. Okay, for the next one, we have negative 1 times negative 2 times 7. So I have two negative numbers involved. 2 is an even number, right? It is divisible by 2. 2 divided by 2 is 1, no remainder. So the answer here will be positive. 1 times 2 times 7 is what we would do next, right? We just think about the numbers as if they're positive. 1 times 2 is 2. 2 times 7 is 14. So your answer here would be 14. Okay, for the next one, let's look at negative 15 times 30 times negative 1 times 2. So I have two negative numbers involved. 2 is an even number, so my answer is going to be positive. Now we just multiply the absolute values of the numbers. So think about 15 times 30 times 1 times 2. So I'm going to save the multiplication times 30 till last, because that's the toughest. So I'm going to reorder this. Put 15 times 1 times 2 times 30. Remember, with multiplication, you can reorder it as much as you want. That is perfectly legal. So 15 times 1 is 15. Then times 2 is 30. So really, I could just think about this problem as 30 times 30. And that's easy to do because we have trailing zeros. You would do 3 times 3. That's 9. And then attach 2 trailing zeros. So you end up with 900. So bring that guy up here. Our answer is going to be positive 900. Okay, for the next one, let's look at 8 times negative 3 times negative 40 times 50 times negative 5. Okay, so we have 1, 2, 3 negative numbers involved here. 3 is an odd number, so my answer is going to be negative. Now I can just work with the absolute values. So I have 8 times 3 times 40 times 50 times 5. So I'm going to leave these numbers with trailing zeros to the end. So let me rewrite this as times 5 times 40 times 50. Okay, so 8 times 3 is 24. 24 times 5 is 120. So we'd have 120 times 40 times 50. So if I'm multiplying, and again, there's trailing zeros involved, you can multiply the non-zero numbers. So 12 times 4 would be 48. And then attach 2 trailing zeros. So 4,800 or 4,800. and then we still have to multiply times 50. So 4,800 times 50. So we do 48 times 5. 48 times 5. 5 times 8 is 40. 5 times 4 is 20, plus 4 is 24. So that's 240. And then we're going to attach 1, 2, 3 trailing zeros. 2, 3. To get 240,000. So we'll come back up here. Remember, the result was negative. We already figured that out. And then we found that multiplying the absolute values gave us 240,000. So our answer for this problem is negative 240,000. Okay, let's practice a little bit of division. So we want to find each quotient. So we have negative 12 divided by positive 12. So again, the sign rules for division are the same as for multiplication. So a negative divided by a positive, the signs are different, so the answer is negative. And then you just work with the absolute values. So 12 divided by 12 would just be 1. So the answer here would be negative 1. Okay, the next one is negative 50 divided by negative 25. So negative divided by negative is positive. Again, the signs are the same, the answer is positive. And then 50 divided by 25 is 2. So we just get positive 2. Now let's look at 45 divided by negative 9. So we have a positive divided by a negative, that's a negative. And then we do 45 divided by 9, and that's 5. So we get negative 5 as our answer there. Okay, now we have negative 36 divided by negative 6. So we have a negative divided by a negative, that's a positive. And then we just do 36 divided by 6, and that's 6. Right, so we get positive 6 as our answer. And then lastly, we have 128 divided by negative 64. So 128 divided by negative 64. Positive divided by negative is negative. And then 128 divided by 64 is 2. So we'd end up with negative 2 as our answer. Hello and welcome to Pre-Algebra Test Section 1 on multiplying and dividing integers. So we want to just find each product. All right, so we're going to begin with negative 3 times negative 7. And what I taught you in the lesson is you figure out your sign first, and then you multiply the absolute values. Here we have a negative times a negative. So when we have the same signs, right, we have a negative times a negative, that's the same, you get a positive result. So the answer will be positive. And then we just think about the absolute values. So what is 3 times 7? That's 21. So negative 3 times negative 7 is positive 21. Next we have 8 times negative 9. So to figure out our sign, we think about the fact that we have a positive times a negative. So if we have different signs, the result is negative. Then you just work with the absolute values. So 8 times 9 would be 72. Put that behind the negative sign, and we get an answer of negative 72. What about 12 times negative 10,000? Well, we have a positive times a negative, so that's a negative. And then for 12 times 10,000, use your trick for trailing zeros. You're going to do 12 times 1, that's 12, and then attach 1, 2, 3, 4 trailing zeros. So 1, 2, 3, 4, and put a comma there. You end up with negative 120,000. Next, let's look at negative 24 times negative 4. So negative times negative is positive. And then what is 24 times 4? 4 times 4 is 16. 4 times 2 is 8. Plus 1 is 9. So we get 96 there. So this will be positive 96. Okay, for the last problem, we have negative 18 times 5. So negative times positive is negative. And then we just do 18 times 5. 18 times 5. 5 times 8 is 40. 5 times 1 is 5. Plus 4 is 9. So that gives me 90. So we'll put that behind that negative sign. And we end up with negative 90 as our answer. Hello and welcome to Pre-Algebra Test Section 2 on multiplying and dividing integers. Okay, so we want to just find each product. So we're going to start out with negative 13 times 9. So as I taught you in the lesson, when you multiply integers, you first figure out what your sign is going to be. Then you just multiply the absolute values. So for a negative times a positive, basically having different signs involved, you're going to get a negative. So once we know the answer is negative, we can just pretend we have 13 times 9. So what is 13 times 9? 9 times 3 is 27. 9 times 1 is 9, plus 2 is 11. So this would give us 117. Now attach it to that negative there, and we get an answer of negative 117. Let's look at 100 times negative 151. Positive times negative gives me a negative. Again, if your signs are different, your result is negative. Now, what is 100 times 151? Use your rule for multiplying with trailing zeros. 151 times 1 is 151. And then attach 2 trailing zeros to the end. And we end up with negative 15,100. What about negative 205 times negative 10? Now we have a negative times another negative. So we have the same signs involved, so our answer is positive. Now just pretend the numbers are positive and multiply. What would 205 times 10 be? Well, again, use your trick for multiplying with trailing zeros. So it's 205, right? 205 times 1 is 205. And then attach 1 trailing zero to the end. And we end up with 2,050 as our answer. What about 28 times negative 2? Well, we have a positive times a negative. So we have different signs involved. So we know this is negative. And then we would just think about 28 times 2, and that's 56. So we end up with negative 56 as our answer. Okay, for the final problem, we have negative 11 times negative 7. So we have a negative times another negative. Same signs, the answer is positive. Then you just multiply with the absolute values. So what is 11 times 7? That's 77. So our answer here is just 77. Hello and welcome to Pre-Algebra Test Section 3 on multiplying and dividing integers. So for our problems, we want to find each product. We're going to start out with 6 times negative 3 times 2. So when we multiply more than 2 integers, we can use a little trick. So we would count the number of negative numbers involved in the problem. So in this case, there's only one, right? We just have a negative 3. The 6 and the 2 are both positive. If the number of negative numbers involved in your problem is an even amount, again, that means it's divisible by 2, your answer is positive. If it's an odd amount, meaning, again, that it's not divisible by 2, your answer is negative. Here we only have 1. 1 is an odd number, so the answer is negative. Once you figure out the sign, you can go through and just multiply the absolute values, right? So just pretend the numbers are positive. So you would just do 6 times 3, that's 18, then times 2, that's 36, to give you negative 36 as your answer. For this problem, we have negative 8 times 7 times negative 4 times negative 1. So we have 1, 2, 3 negatives involved. 3 is an odd number, so the answer is negative. Now we just go through and multiply the absolute values. So we have 8 times 7, that's 56, then times 4. So think about 56 times 4. 4 times 6 is 24. 4 times 5 is 20, plus 2 is 22. So we would essentially have 224 times 1, which is just 224. So now we attach that to the negative sign, and we get an answer of negative 224. Okay, now let's look at negative 1 times 5 times negative 12 times 9. So we have 2 negatives involved. 2 is an even number, so the result is positive. Now we can think about multiplying the absolute values. So 1 times 5 is 5. 5 times 12 is 60. And then 60 times 9, I can do by using my trick for trailing zeros. I would do 6 times 9, that's 54. And then I would attach 1 trailing zero to the end. So this is going to be positive 540 for our answer. Okay, let's take a look at 17 times negative 3 times 1 times 0 times negative 81. Now, most of you are going to start this problem by saying, okay, I have 2 negatives involved. 2 is an even number, so this is positive. The reason you don't do that here is because you have a 0 as a factor. Whenever you have 0 as a factor, the answer is just 0, okay? 0 is also not positive or negative, so you don't need a positive or negative sign. It's just 0. Now, one of the things you can think about here is that whatever the result is of the multiplication through here, once you multiply by 0, you're done, right? The answer is 0. And then 0 times anything after that is always 0. So anytime you have 0 as a factor, and you just have multiplication involved, again, your answer is 0. Okay, let's take a look at the last one. We have 11 times 10 times negative 3 times negative 1. So we have 2 negatives involved. 2 is an even number, so the answer will be positive. And then we just multiply the absolute values. So 11 times 10 I can think of as 11 times 1. That's 11. Put a 0 at the end. It's 110. Then I'd multiply times 3 times 1. So 110 times 3 times 1. So 110 times 3, I can think about that as 11 times 3, that's 33. Attach a 0 to the end. Then this 330 times 1 would just still be 330. Okay, so my answer here for this problem is going to be 330. Hello and welcome to Pre-Algebra Test Section 4 on multiplying and dividing integers. All right, so we just want to find each quotient. And to begin, we have -3 divided by 1. Now, when we divide integers, we use the same sign rules as when we multiply integers. So here we have a negative divided by a positive. We have different signs, so the result is negative. Once you figure out your sign, you just divide the absolute values. So you just think about 3 divided by 1 is 3. Put that behind your negative sign, and you get -3 for your answer. Okay, next we have -4 divided by -2. So if I have a negative divided by another negative, the answer will be positive. Right? If I have the same signs, right, a negative and a negative, the answer is positive. So then I think about the absolute values. 4 divided by 2 is just 2. So the answer here is just 2 or positive 2. Next, let's do 10 divided by -5. We have a positive divided by a negative. So different signs involved, we're going to have a negative result. And then you just do 10 divided by 5, and that's 2. So we get -2 as our answer. Now we have 25 divided by -5, and so we have a positive divided by a negative. Different signs, you get a negative result. Then we do 25 divided by 5, and that's 5. So we have -5 as our answer. Okay, for the final problem, we have -300 divided by -10. So we have a negative divided by another negative. We have the same signs, so the answer is positive. So now we just do 300 divided by 10, and that's going to give us 30. So we end up with +30 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on multiplying and dividing integers. Okay, so we want to just find each quotient. And we're going to start out with -42 divided by -7. So what we're going to do here is figure out what our sign is first, and then we'll just divide the absolute values. So when we have a negative divided by another negative, the answer will be positive. Again, if you have the same signs, the answer is positive. If you have different signs, the answer is negative. So now that we know that the sign is positive, we just think about the absolute values now. So we would think about 42 divided by 7, that's 6. And we already know the answer was positive, so we get +6 or just 6 as our answer. Next, let's think about -81 divided by 9. So we have a negative divided by a positive. So we have different signs involved. The answer is negative. Now we would think about the absolute values. So 81 divided by 9 is 9. So our answer here is -9. Okay, now we have 200 divided by -5. So we have a positive divided by a negative. So positive divided by a negative. Again, different signs, you get a negative. Now what's 200 divided by 5? Some of you might need to do a long division for that. But basically, if you think about what times 5 would give you 200, well, I know that 4 times 5 would give me 20, right? 4 times 5 equals 20. Now, thinking about the trailing 0 thing that we've learned, I have another 0 at the end of 20. I have 200, right, if I put a 0 there. So if instead of 4, I had a 40, okay, I had a 40, then this would be 200, right? Because I'd multiply 4 times 5 and get 20 and put a 0 at the end. So my answer here is that 200 divided by -5 is negative and then 40. We have 10,000 divided by -1,000. So we know the answer is negative, right? Positive divided by negative is negative. And then we think about, okay, what times 1,000 would give me 10,000? I can see that 1,000 has one less 0 than 10,000, right? So if I multiply, I'm going to multiply by a number that has 1 0 on it. So it'll be a 1 with 1 0. So that's the number 10, right? 10 times 1,000 would be 10,000. And so the answer here would be -10. All right, for the final problem, we have -45 divided by -15. And so negative divided by negative is positive. And then thinking about 45 divided by 15, Some of us will need to do a long division for that, but really just think your way through it. So you have 45 divided by 15 equals what? So then what times 15, what number times 15 would equal 45? Well, just thinking about this using repeated addition, if I had 15 plus 15, that would be 2 times 15, that's 30. If I add 15 more to that, meaning 3 times 15, so 15 plus 15 plus 15, that's 45. That's exactly what I'm looking for. So it would be 3 times 15 to get to 45. So the answer here would be 3. Hello and welcome to Pre-Algebra Practice Set number 22. And in this video, we're going to look at some additional practice problems for our lesson on exponents with an integer base. Okay, so for our problems, we just want to evaluate. And we're going to start out with -1 raised to the power of 8. Now I want you to pay close attention here. We have parentheses around this number -1. So that means both the negative part and the 1 are raised to the power of 8. So essentially what I'd have here, if I went through this the long way, I'd have -1 times -1 times -1 times -1, and I'll continue this down here, times -1 times -1 times -1 times -1, right? 8 factors of -1. 1, 2, 3, 4, 5, 6, 7, 8. Now, from our knowledge of multiplying integers, I know that if I have an even number of negative factors, I'm going to get a positive result. So this would be positive, and I wouldn't need to think about the sign anymore. I could just multiply with the absolute values. So 8 factors of just 1 would give me a result of 1. I could multiply 1 times itself as many times as I want. I will always get 1 as a result. So that's pretty easy. So I'd end up with +1. But now the shortcut, let me just erase this real quick. The shortcut here is just to realize that, okay, if I have my negative number inside of a set of parentheses and I have an even exponent, the answer will be positive. Okay, the answer will be positive. Because again, I'm just going to have an even number of negative factors. Now the next thing is to think about, what's the number part going to be? I got the sign, what's the number? Well, just thinking about the absolute value of this, it would just be 1. And I can think about, well, what is 8 factors of 1? Well, 8 factors of 1 would just be 1. So I'd end up with +1 as my answer. Now, you have to pay close attention, again, to whether or not you have parentheses around the number or not. If I had -1 to the 8th power written like this, I don't get the answer of 1. I get the answer of -1. And if you didn't watch the lesson, you might be saying, well, why is that the case? Go ahead and type this up on your calculator. Put parentheses around -1 and put in to the 8th power, you'll get 1. Don't put parentheses around -1 and put it to the 8th power and you'll get -1. And the reason for this is because I'm saying, hey, what's the opposite? What's the opposite of 1 raised to the 8th power? I could basically write this as -1 times 1 to the 8th power. And then we'd see that we'd have 1 to the 8th power is 1. So you'd have -1 times 1, and that would give you -1. So you have to pay close attention to whether or not you have parentheses around your base if the number is negative. If you don't, the answer is always going to be negative. If you do, the answer is positive if your exponent is even, like in this case. It's going to be negative if your exponent is odd, like in this case that we're going to get to in a second. So if we have -1 inside of parentheses raised to the 5th power, I would get a negative. And the reason for that is I'd have an odd number of negative factors that gives me a negative result. So this would be -1. Right? I know the sign would be negative, and then 1 to the 5th power is just 1, so I'd get -1. Here I have -1 to the 28th power. And again, it doesn't matter here that the exponent is even. If I don't have parentheses around the base, I'm going to get a negative result. That's just the way it works, because I basically have -1 times 1 to the 28th power. This is a notational issue, right? It'll come up. You have to pay close attention when you're working with these negative numbers. So I would have what? -1 times 1. 1 to the 20th power is just 1, and that gives me -1. Here we have -6 to the 4th power. Negative 6 is not enclosed inside of a set of parentheses. So again, this can be written as negative 1 times 6 to the 4th power. And because of the order of operations, we do 6 to the 4th power first. That's 6 times 6, that's 36, times 6, that's 216, and then 216 times 6 is 1,296. So I'd have negative 1 times 1,296, which is negative 1,296. Again, I don't have parentheses around the base, so it doesn't matter that this exponent is even. I get a negative result either way. Now here's the same problem with a different notation. We have parentheses around negative 6 now, and it's raised to the 4th power. So this is negative 6 times negative 6 times negative 6 times negative 6. The negative and the 6 are being raised to the 4th power. So we'd have what? We'd have positive 1,296. Essentially, the sign now is determined by the exponent. How many negative factors are we going to have? Well, we have 4. That's an even number, so the answer is positive. And then the 6 to the 4th power part is the same. 6 to the 4th power, again, is 6 times 6, that's 36. Times 6, that's 216. Then times 6 one more time, which is 1,296. What about negative 3 cubed with no parentheses around the base? Well, in this case, again, if there's no parentheses around the base, it's always going to be negative. So the sign's negative, and then you can just think about what is 3 cubed. Well, 3 cubed is 3 times 3, that's 9. Then times 3, that's 27. So this is negative 27. But what's interesting here is that if I had parentheses in this case around negative 3, I'd still get a negative 27. And the reason for that is I'd have negative 3 times negative 3 times negative 3. I would have an odd number, right, 3. I'd have an odd number of negative factors, which gives me a negative result. So I get negative 27 here as well. And if this had been an even exponent, so for example, if we were working with the problem, let's say negative 3 to the 4th power like this, well, this part would be negative. We'd have negative, and then 3 to the 4th power. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So you'd have negative 81. And then when you put this inside of parentheses, now I'm thinking about, okay, well, this exponent is even, so I'd get a positive 81, right? Because I'd have an even number of negative factors. So that gives me a positive, and 3 to the 4th power is 81. So when this is even, and it's inside of parentheses, you will get a positive result. When this is odd and inside of a set of parentheses, you will get a negative result. And when you don't have parentheses around your base and it's negative, you always get a negative result. Okay, let's think about negative 2 to the 7th power. So we have parentheses around the base here, but our exponent is odd. And when we have an exponent that's odd, we're going to get a negative result. So we just think about 2 to the 7th power now. 2 to the 7th power is 128. So we'd end up with negative 128 as our answer. What about negative 10 inside of a set of parentheses raised to the 6th power? Well, this is an even number here, and my negative 10 is inside of parentheses, so I'd have an even number of negative factors. That would give me a positive result. Now I just think about 10 to the 6th power. Remember your trick. If you have 10 to the 6th power, you write a 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. So that gives me positive 1 million. Next, we're going to look at negative 10 to the 4th power. But even though this is even, remember, we don't have parentheses around the base. So if there's no parentheses around the base, in this scenario, you're going to get a negative result. Because I'm saying, hey, what's the opposite of 10 to the 4th power? And the opposite of 10 to the 4th power, 10 to the 4th power is a 1 followed by 4 zeros. 1, 2, 3, 4. So this would be negative 10,000. Right? It'd just be the opposite of 10,000, which again is negative 10,000. Okay, now we're just going to determine if the sign will be positive or negative. So let's start out by looking at negative 51 squared. Notice how there's no parentheses around the base, and so the result will be negative. Next, we're going to look at negative 139 cubed. So we do have parentheses around the base here, but the exponent is odd. So that's going to give me a negative. I'd have an odd number of negative factors. That's going to give me a negative result. Okay, next let's look at negative 38 to the fourth power. Now notice how the negative 38 is enclosed inside of a set of parentheses. So now I'm looking at this exponent here. So the exponent is a 4. That's an even number. So if I had an even number of negative factors, the result would be positive. Okay, now we have negative 2 to the 8th power, and the negative 2 is enclosed inside of a set of parentheses. So I'd look at the exponent. So that's an 8. 8 is an even number, so my answer would be positive. Next, I have negative 855 raised to the 5th power. It's enclosed inside of a set of parentheses, so I look at my exponent. My exponent is a 5. 5 is an odd number, so this would be negative. Okay, now let's take a look at negative 75 to the 6th power. But notice how you don't have parentheses around negative 75. So that tells me that the result will be negative, because I basically have the negative of 75 to the 6th power, or the opposite of 75 to the 6th power. So I would do 75 to the 6th power first, and then when I'm done, I would change the sign, which would make it negative. All right, what about negative 104 raised to the 19th power? Well, again, there's no parentheses around negative 104, so the result is going to be negative. And for our last problem, we have negative 212 raised to the 22nd power. So because this is enclosed inside of a set of parentheses, I look at my exponent and I say, is it odd? Is it even? 22 is an even number. It's divisible by 2. 22 divided by 2 is 11 with no remainder. So because of that fact, this will be positive. I would get an even number of negative factors, which gives me a positive result. Hello and welcome to Pre-Algebra Test Section 1 on exponents with an integer base. Okay, so for our problems, we just want to evaluate each. We're going to start out by looking at negative 2 raised to the 8th power. We have to pay close attention when we're working with exponents and we have a negative base. In this case, we can see that we have parentheses around the negative 2. So when this occurs, I'm essentially going to have negative 2 times 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 negative 2. 8 factors of negative 2. Now, we know that if I have an even number of negative factors, the result is positive. Then I could just go through and multiply absolute values. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, and then 128 times 2 is 256. But an easier way to look at this, if you have parentheses around your base, then the negative and the 2 are raised to this exponent, which is 8. 8 is an even number. So again, we know we'd have a positive result because I'd have an even number of negative factors. Then I could just think about what is 2 to the 8th power, and we found that was 256. So this is, again, positive 256. What about negative 2 cubed? Well, notice again how I have parentheses around my base, so the negative and the 2 are both raised to the 3rd power. But because this exponent is a 3, I'm going to get a negative result. And the reason for that is I would have an odd number of negative factors. Right? I'd have negative 2 times negative 2 times negative 2. So I would get a negative result. Now I can just think about what is 2 cubed. Right? What is 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8. So this would be negative 8 as my answer. Now let's take a look at negative 2 to the 8th power. And you might say, we already did this problem. No, we didn't. I want you to pay close attention to the fact that we don't have parentheses around negative 2. So essentially what this is telling you is that I have negative 1 times 2 to the 8th power, or the opposite of 2 to the 8th power. We found earlier that 2 to the 8th power was 256. This is negative 1 times 256, which is equal to negative 256. Have to pay close attention to whether or not you have parentheses around that base. If we had negative 2 to the 8th power like this, again, we solved this earlier, we know we would get 8 factors of negative 2. An even number of negative factors gives us a positive result. So this would be positive 256. The difference is having parentheses around the base tells us that the negative and the 2 are raised to that power of 8. When we don't have it, it's just the opposite of 2 to the 8th power. What about negative 2 cubed? And notice how, again, there's no parentheses around the negative 2. So again, this is just the opposite of 2 cubed. You just think about it as negative 1 times 2 cubed. 2 cubed is 8. You just multiply negative 1 times 8, and you get negative 8. And you might stop and say, okay, well, we did negative 2 cubed earlier like this, and we got negative 8 as well. Yeah, that's true. In this case, you'd have negative 2 times negative 2 times negative 2. But just notice that the reason it's negative is not the same here. This is negative because we have an odd number of negative factors. This is negative because I'm saying, hey, I want the opposite of 2 cubed, or basically what is negative 1 times 2 cubed. So they're negative for different reasons. Okay, for the last one, we have negative 2 to the 4th power. Now again, notice how this negative 2 is enclosed inside of a set of parentheses. So in this case, the negative and the 2 are raised to the 4th power. Now thinking about this exponent here, it's a 4. 4 is an even number. So I would have an even number of negative factors, so my result would be positive. Right? So now I just think about what is 2 to the 4th power. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So my answer would be positive 16. Hello and welcome to Pre-Algebra Test Section 2 on exponents with an integer base. Okay, so we want to evaluate each. We start out with negative 10 to the 2nd power, otherwise known as negative 10 squared. Now I want you to notice something. We don't have any parentheses around negative 10. So when you work with exponents and your base is negative, you have to pay attention to this. If there's no parentheses around the base, then you're basically saying that you want the opposite of 10 squared. So to make that clear, I'm going to write negative 1 times 10 squared. Because of the order of operations, I would say, what is 10 squared first? 10 squared is 100. So I would say, what is negative 1 times 100? And that is negative 100. Now, if I come to this problem here, negative 10 squared, where there's parentheses around the negative 10. Now what I'm saying is, hey, what is negative 10 times negative 10? The negative and the 10 are both raised to the 2nd power. So in this case, I have a negative times a negative, and that's a positive, right? An even number of negative factors gives you a positive result. And then I just think about what's 10 times 10, and that's 100. So in this case, we have positive 100. And again, in this case up here, we have negative 100 because I essentially said, hey, what's the opposite of 10 squared? All right, next we're going to look at negative 10 cubed. But again, no parentheses around the base. So if there's no parentheses around the base, it's going to be negative because you're saying, what is the opposite of 10 cubed? Now, 10 cubed, you can think of as a 1 followed by 3 zeros. 1, 2, 3. So we end up with a negative 1,000 as our answer. What is negative 10 to the 5th power? Again, no parentheses around the base. So if there's no parentheses around the base, it's going to be negative. And then 10 to the 5th power is a 1 followed by 5 zeros. 1, 2, 3, 4, 5. So that's negative 100,000. All right, for the last problem, we have negative 10 cubed again, but now we have parentheses around our base. So what's different here is instead of me saying, in this scenario, I had the opposite of 10 cubed. And so essentially I had negative 1 times 10 cubed is 1,000. So this equals negative 1,000. Here I'm saying I want negative 10 times negative 10 times negative 10. Now this is going to be negative as well, but it's just negative for a different reason. It's negative because we have 3 negative factors. So 3 negative factors, 3 is an odd number, you get a negative result. 10 times 10 times 10 is 1,000, as we already know. So we get negative 1,000 as well. Hello and welcome to Pre-Algebra Test Section 3 on exponents with an integer base. Okay, so we just want to evaluate each. And we're looking at negative 5 squared to start. And basically what I taught you in the lesson is that you need to pay close attention to whether or not you have parentheses around your base if it's negative. So in this case, we do. We have parentheses around negative 5, And so this problem translates into -5 times -5, right? Negative times negative is positive, and 5 times 5 is 25. Or you could also say, okay, I have an even number of negatives here, so I know the answer is positive. Again, 5 times 5 is 25. This answer is going to be different than when we work the problem this way. Now I have -5 squared, but notice how I don't have parentheses around -5. So what this is telling me is that I have the opposite of, or the negative of, 5 squared. I could write this as -1 times 5 squared. Now, because of the order of operations, I would do 5 squared first. 5 squared is 25, so I would have -1 times 25. This is basically saying I want the negative of 25, or the opposite of 25, which is -25. So you have to pay close attention to whether or not you have parentheses around your base, particularly when your exponent is even. Because in this scenario up here, we've got parentheses around the base, the exponent is even, so I had an even number of negative factors. That gave me a positive result. Here, I have no parentheses around the base. I have an even exponent, but because I don't have parentheses around the base, I'm asking for what is the opposite of 5 squared, and that's why I got a -25. Okay, here we have -5 cubed, and we have parentheses around our base. Now, in this case, I'm going to get a negative. And the reason is, although this is -5 times -5 times -5, I have 3 negative factors. 3 is an odd number, so that tells me I'm going to have a negative result. Now we just think about 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So this is -125. Now down here I have -5 cubed also, but I didn't write any parentheses around -5. So essentially this is telling me I have the opposite of five cubed. Right, so I'm going to write that as -1 times 5 cubed. 5 cubed is 125, so this would be -1 times 125, which is -125. It's the same answer either way, but we arrive at it differently. Here I have the opposite of 5 cubed, which is the opposite of 125, or -125. Here I had 3 factors of -5, which again, 3 is an odd number, so that's negative, and then 3 factors of 5 is 125, so I get -125. Okay, so now in this scenario, we have -5 to the 4th power, and we have parentheses around -5. Now, I'm basically saying -5 times -5 times -5 times -5, right? The negative and the 5 are raised to the 4th power. So I'm looking at the exponent, and it's even. So my answer is positive, and I just think about what is 5 to the 4th power. 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. So this is positive 625. Now, when we get to this right here, this -5 to the 4th power, we notice that we get a negative. The exponent is even, but this is basically saying I want the opposite of 5 to the 4th power. The opposite of. And again, that's a notational thing because we don't have parentheses around the negative and the 5, right? So this is saying, hey, I want -1 times the result of 5 to the 4th power. 5 to the 4th power is 625. So you end up with -625 as your answer. Hello and welcome to Pre-Algebra Test Section 4 on exponents with an integer base. Okay, so for the problems we're going to look at, we're just going to determine the sign only. We don't need to answer it. So we're going to start out with -2 to the 15th power. And we're looking at the fact that we do have parentheses around the base. But we have a 15 for our exponent. 15 is an odd number. So I would have an odd number of negative factors. That would give me a negative result. So my sign would be negative. Next we look at -8 to the 12th power. The -8 is inside of a set of parentheses. So I would have 12 factors of -8. Now 12 is an even number. An even number of negative factors gives me a positive result. What about -3 to the 4th power? Well, notice how there's no parentheses around -3. So essentially what this is saying is that I have the opposite of 3 to the 4th power. So I would do 3 to the 4th power first. That would be positive. And then I'd take the negative of that, or I'd take the opposite of that, and it would become negative. Again, if you don't have parentheses around the base and it's negative, the result is always negative. Here we have negative 7 cubed and no parentheses around the base. And as I just said, when this occurs, the result is always negative. You'd have 7 cubed done first, then you would take the opposite of that and it would become negative. All right, we have negative 1053 to the 4th power. So we do have parentheses around the base here. And our exponent is even. So that tells me that we're going to have an even number of negative factors. That would give me a positive result. All right, for the last one, we have negative 264 raised to the 13th power. Parentheses around the base here. So we're looking at our exponent. Our exponent is odd. So an odd number of negative factors gives me a negative result. Hello and welcome to Pre-Algebra Test Section 5 on exponents with an integer base. Okay, so for these problems, we're just going to determine the sign only. So we're going to start out with negative 7 to the 10th power. So notice how we have parentheses around negative 7. So that tells me I'm going to have 10 factors of negative 7. 10 is an even number. An even number of negatives gives me a positive result. Next, I have negative 4 to the 5th power. Now, although this is inside of a set of parentheses, it's still going to be negative. And the reason is because I have 5 factors of negative 4. 5 is an odd number. An odd number of negative factors is going to give me a negative result. What about negative 8 to the 19th power? Well, negative 8 is inside of a set of parentheses here, but it's raised to an odd number, right? An odd number of negative factors gives me a negative result. Next, we have negative 12 to the power of 51. Now, you might look at this and say, okay, well, this is odd, and so it's negative. But really, we don't have parentheses around the base. So when we don't have parentheses around the base, this is going to be negative. Right? Because I'm basically saying the opposite of 12 to the power of 51. Next, we have negative 1027 raised to the 16th power. So again, although this is even, we don't have parentheses around the base. So what's happening is I'm saying I want the opposite of 1027 raised to the 16th power. So this part would be positive, the 1027 raised to the 16th power. But then this, we'd say, well, what is the opposite of that? That would make it negative. Now we have negative 815 raised to the 97th power. Now we have parentheses around our base, but this number here, our exponent, is odd, so we get a negative result. Now we have negative 10,577 raised to the power of 113. And again, we have parentheses around our base, but this number right here, our exponent, is odd, so our answer is negative. For our final problem, we have negative 155,375 raised to the power of 17. Now, no parentheses around the base, so we know it's negative. Hello and welcome to Pre-Algebra Practice Set number 23. And in this video, we're going to look at some additional practice problems for our lesson on the order of operations with integers. Okay, so for the problems we're going to look at, we just want to evaluate each. And we're going to start out with this. We have inside of parentheses 48 times 2 minus a negative 12. Then we're dividing by 9. Then we're subtracting away. Inside of parentheses, we have 8 plus, and then inside of absolute value bars, negative 17 minus 6. So if we look at this problem, we have parentheses here, and we have parentheses here. And it doesn't really matter which one you start inside of first. As long as you completely take care of this one, and you completely take care of this one, before you start doing any of the operations that are outside of the parentheses, you are fine. So let's start with the parentheses here. Now, if I look, it looks like I have parentheses again right here, but again, this is just used to separate the minus a negative so that we don't have two operator symbols next to each other. So what I'm looking at is multiplication and subtraction. So I want to multiply before I subtract. So what is 48 times 2? 48 times 2. 2 times 8 is 16. 2 times 4 is 8, plus 1 is 9. So that would be 96. All right, so I'm going to replace that. We'll have inside of parentheses 96 minus a negative 12. I can go ahead and write that as plus 12. Right? Minus a negative is plus a positive. And then we'll have divided by, we have this 9 minus, and then inside of parentheses we have 8 plus, and then inside of absolute value bars, negative 17 minus 6. Okay. So continuing inside of here, I just have addition. 96 plus 12. 96 plus 12. 6 plus 2 is 8. 9 plus 1 is 10. So that's 108. So I'll replace this with 108. And then I have divided by 9. And then minus. And I can go ahead and just start working inside of the parentheses here, because that would be my next step. So if I look inside the parentheses here, I have addition, and then I have some absolute value bars. Now, I always want to look for grouping symbols when I get inside of grouping symbols, right? Because I'm reapplying the order of operations. So this right here would serve as grouping symbols. We need to figure out what negative 17 minus 6 would be. Negative 17 minus 6 is the same thing as if I said, what is negative 17 plus negative 6? The answer would be negative, right? We have a common sign. And then you just do 17 plus 6, and that's 23. So this would be negative 23. So let's write this as 8 plus the absolute value of negative 23. So now continuing inside of our parentheses here, we need to figure out what the absolute value of negative 23 is first before we can add to 8, right? So the absolute value of negative 23 is 23. So we would have 108 divided by 9 minus, and then inside of parentheses we'd have 8 plus, the absolute value of negative 23 is 23. So now continuing inside of the parentheses, 8 plus 23 is 31. So we'd have 108 divided by 9 minus, again, 31. So now the problem is very, very simple. We have division and we have subtraction. So I want to divide before I subtract. So what is 108 divided by 9? So I don't know that off the top of my head. So we could quickly do a long division and figure that out. So 9 goes into 10 once. 1 times 9 is 9. Subtract here, you get 1 and bring down the 8. 9 goes into 18 twice. 2 times 9 is 18. Subtract and get 0. So the answer for that is 12. So again, 108 divided by 9 is 12, and then we're subtracting away 31. So 12 minus 31. We can change this to 12 plus a negative 31 and use our rules for adding integers. So the first thing you would do is find the sign. The sign is going to be negative because negative 31 has a larger absolute value. Then I would subtract the smaller absolute value from the larger. So I would do 31 minus 12. Borrow here. 11 minus 2 is 9. 2 minus 1 is 1. So the answer would be negative 19. Okay, let's take a look at another one. And realistically, this should be up here. It's just, it doesn't fit on the screen, so it had to continue on the next line. And I apologize for that. But we have 3 plus, and then inside of brackets, we have this quantity 29 minus 6, then times 13. Then we're dividing by, and then inside of these parentheses, we have negative 17 minus, inside of another set of parentheses, negative 2 times 2, and then we subtract away 26. So I'm going to start inside of grouping symbols, and I have brackets here. I have parentheses here. So I'm going to start inside of these brackets, and once I get inside, I'm looking at the innermost set of grouping symbols, and that contains 29 minus 6. So 29 minus 6 is 23. So I'm going to put 3 plus, and then inside of brackets, I'm going to have 23 times 13. Then this is going to be divided by, inside of parentheses, we have negative 17 minus, and then we have inside of parentheses, negative 2 times 2, and then we're subtracting away 26. So staying inside the brackets, I have 23 times 13. So I don't know what that is off the top of my head. So let's do a vertical multiplication. 23 times 13. 3 times 3 is 9. 3 times 2 is 6. Then 1 times 23 is 23. So put the 3 here and the 2 here. Bring down the 9. 6 plus 3 is 9. Bring down the 2. So 299. So we're going to have 3 plus 299. Then we're dividing by, and then inside the parentheses here, I have a negative 17 minus. Now, once I get inside these parentheses, remember, I would go to this set of parentheses right here, and I would evaluate what is negative 2 times 2. Well, negative 2 times 2 is negative 4. Negative times positive is negative, and 2 times 2 is 4. So this would be minus a negative 4, and then we have minus 26. So continuing inside of these parentheses here, I have negative 17 minus a negative 4. That's the same thing as negative 17 plus a positive 4. So if we think about what is negative 17 plus 4? Well, the sign is negative. And then I would just do 17 minus 4. 17 minus 4 is 13. So that's negative 13. So we'll have 3 plus 299 divided by, again, this is negative 13, and then minus 26. So we're done with all the grouping symbols. Now all we need to do is look at our operations involved. We have addition, division, and subtraction. And remember, although we have parentheses here, the only reason those parentheses are there is so I don't have division and then a subtraction symbol right next to each other because it looks clustered, right? So that's why we have parentheses there. All right, so now I want to divide before I do anything else. So what is 299 divided by negative 13? Well, I know it's negative, but what's 299 divided by 13? 13 goes into 29 twice. 2 times 13 is 26. Subtracting, we get 3. Bring down the 9. 13 goes into 39 exactly 3 times. 3 times 13 is 39. Subtracting gets 0. Okay, so we're going to get negative 23. So we'd have 3 plus a negative 23, and then minus a 26. So all I have now is addition and subtraction. So we work those left to right. So 3 plus negative 23 is going to be negative 20. Right? Keep the sign that has the larger absolute value. In this case, that's negative 23. So the answer is negative. And then subtract the smaller absolute value, which is 3, from the larger absolute value, which would be 23. 23 minus 3 is 20. So you get negative 20. Now we're subtracting away 26. Now I can just think about this as negative 20 plus negative 26. The sign would be negative, right? Use the common sign. And then just add the absolute values. 20 plus 26 is 46. So our answer here is negative 46. Okay, for the final problem, we have this quantity, negative 12 minus 8. Then we're dividing by, we have the absolute value of negative 2 times negative 5 plus negative 6. Then we're dividing by the absolute value of 3 times negative 9 minus a negative 22. So we have grouping symbols here. The absolute value bars are going to serve as grouping symbols here and here. So what this basically tells us is, hey, figure out what this is, figure out what this is, and figure out what this is separately. Figure those results out first before you do any of the division, right? You just have to separate that. It's grouping those operations together. So I'm going to start out and just work with negative 12 minus 8 first. But it really doesn't matter. If I started with inside these absolute value bars, and then I went to this, and then I went back to that, as long as I do everything separately before I do this division, I'm okay. So negative 12 minus 8 is the same thing as negative 12 plus negative 8. That's negative 20. Okay, so now inside these absolute value bars, I have a negative 2 times a negative 5 plus a negative 6. So multiplication and addition. Now I want to multiply before I add. So negative 2 times negative 5 is going to give me positive 10. So the absolute value of 10, and then we're adding negative 6. That's basically the same thing as subtracting away 6. So I'm going to write this as 4. because 10 plus negative 6 or 10 minus 6 is 4. So we'd have the absolute value of 4 here, then divided by, let me write the rest of this, we have the absolute value of 3 times negative 9. Then minus the negative 22 I could just think of as plus 22. Now inside these absolute value bars I have multiplication and I have addition. So I would multiply first. What is 3 times negative 9? Positive times negative is negative. 3 times 9 is 27. So this is going to give me a negative 27. So I'd have negative 20 divided by the absolute value of 4 divided by the result of this, the absolute value of, this would be negative 27 plus 22. Now if I perform this operation, negative 27 plus 22, it's going to be negative 5. So we'll rewrite this as negative 20 divided by the absolute value of 4 divided by, and then this will be the absolute value of negative 5. So now I'm going to perform these absolute value operations. So I'm going to have negative 20 divided by the absolute value of 4 is 4, and then divided by the absolute value of negative 5 is 5. So now I just have division, and I'm going to work left to right. So negative 20 divided by 4 is negative 5. That's negative 5. And then we're dividing by 5. Negative 5 divided by 5 is negative 1. Hello and welcome to Pre-Algebra Test Section 1 on the order of operations with integers. Okay, so we want to evaluate each, and we're just looking at one problem here. So inside of brackets we have parentheses around negative 1 minus a negative 21, then times 2. Then we're dividing by this quantity, 9 plus 1. Then we're subtracting away. We have negative 15 squared. So we want to always start out by working inside of grouping symbols. So we have brackets here. We have parentheses here. And I know we have parentheses here, but this is just to enclose that negative that's being raised to the second power. So if I look inside the brackets here, I have a set of parentheses. So when we work inside of grouping symbols, we always look to reapply the order of operations. And when we do that, we look for grouping symbols again. So we start with the innermost set, and that contains negative 1 minus a negative 21. And when you do minus a negative, it's plus, you can think of this as plus a positive. So what is negative 1 plus 21? Well, that's going to be 20. You can think about that as 21 minus 1. It's just 20. So inside these brackets, I'm going to have 20 times 2. And I might as well go ahead and just do that now. 20 times 2 is 40. So let's just replace this with 40. And we can remove the brackets. So we'll just have 40 there. Now next we have divided by. We have this quantity 9 plus 1. We would do that next. What is 9 plus 1? That's 10. So then we put a 10 there. And then we have minus. And then we have this negative 15 that's being squared. Now we have division. We have subtraction, and we have an exponent. We want to perform the exponent operation first. So what is negative 15 squared? Well, notice how you have parentheses around your base, negative 15. So that means I have two factors of negative 15, and that's positive 225. So I'll have 40 divided by, we have 10 minus, again, this is positive 225. Now I have division and subtraction. So I want to divide first. So what is 40 divided by 10? That's 4. So we'd have 4 minus 225. And we could rewrite this as 4 plus negative 225. So I know the sign is negative. And then I'm just going to subtract absolute values. Right? I do 225, which is the larger absolute value, minus 4, which is the smaller absolute value. 5 minus 4 is 1. Then bring down this 2 and this 2, and you get 221. So we drag that back up here, and our answer for this problem is negative 221. Hello, and welcome to Pre-Algebra Test Section 2 on the order of operations with integers. Okay, so we just want to evaluate each, and we only have one problem. So we have negative 24 plus 3 plus 8 minus, and then inside these brackets, it kind of got cut off. It doesn't fit on my screen, but inside the brackets, we have this quantity, negative 1 plus 13, and that's squared. And then minus, you have this quantity 2 plus 13. So let's start out. I'm just going to recopy this. Negative 24 plus 3 plus 8 minus. Now, we're going to start out inside these brackets here. And once we get inside the brackets, we have two sets of parentheses. I have one here, and I have one here. Now, it doesn't matter which one you start inside of. I can just start with negative 1 plus 13. That would be positive 12. So inside the brackets, we'd have a 12 squared. And then minus, I would still have this part right here, this 2 plus 13. I can go ahead and just take care of that. So 2 plus 13 is 15. So 15. And continuing inside the brackets there, remember, I always have to reapply my order of operations. I have this exponent and I have subtraction. So doing the exponent is more important. So what is 12 squared? Well, I could go through and do a vertical multiplication with 12 times 12, but I already know this is 144. 2 times 2 is 4. 2 times 1 is 2. And then 1 times 12 is 12. Bring down the 4. 2 plus 2 is 4. Bring down the 1. Again, 144. So I'd have negative 24 plus 3 plus 8 minus, and then inside the brackets, I'd have 144 minus 15. So what is 144 minus 15? You can kind of use a little mental trick for this. If I had 145 minus 15, that's easy to do in your head. That's 130. But I have one less than that. So I'd end up with 129, right? Because I started out with one less than 145. So my answer should be one less, right? So I'd end up with 129. So this is negative 24 plus 3 plus 8 minus 129. Now I just have addition and subtraction, so I can work left to right. So negative 24 plus 3 is negative 21. Negative 21. Then plus 8, then minus 129. So negative 21 plus 8, we know the answer is negative, and you just do 21 minus 8. Borrow here, 11 minus 8 is 3. Bring down the 1, so that's a negative 13. And then minus 129. Now, if I'm subtracting away 129, it's the same thing as adding negative 129. So I'm going to change this to plus negative 129, like that. The sign would be negative, and then we just add 129 and 13. 9 plus 3 is 12. 1 plus 2 is 3, plus 1 is 4. Bring down the 1. So we'd end up with negative 142 as our answer. Hello and welcome to Pre-Algebra Test Section 3 on the order of operations with integers. All right, so we want to just evaluate each. So for our problem, we have inside of parentheses negative 30 times 2, then divided by, inside of brackets, we have this quantity, 28 minus 26, then times, we have another quantity here, negative 19 minus a negative 13. So we have multiple grouping symbols here. We have parentheses here, and then we have brackets here. Now it doesn't matter which one I do first. I just need to figure out the result of the parentheses here and the result of the brackets here before I tackle that division. So let's figure out what negative 30 times 2 is first. Just get that out of the way. So negative 30 times 2, negative times positive is negative. 30 times 2 is 60, so that's negative 60. So now once I look inside the brackets, I notice that I have parentheses here and here. It doesn't matter which one I start inside of, but I need to figure out what this is and this is before I tackle that multiplication. So what is 28 minus 26? Well, that's going to be 2. So I'm going to put divided by, and then inside the brackets, I'll write this as 2 times. Next, I would think about negative 19 minus a negative 13. Minus a negative is plus a positive. So really, this is negative 19 plus 13. That's going to give me negative 6. So this will be 2 times a negative 6. So now I would just perform the operation inside the brackets. 2 times negative 6 is negative 12. So we'd have negative 60 divided by a negative 12. And negative divided by negative is positive. And then 60 divided by 12 is 5. So my answer here is 5. Hello and welcome to Pre-Algebra Test Section 4 on the order of operations with integers. All right, so we just want to evaluate each. And we're only looking at one problem here. So we have inside of brackets, this quantity negative 18 plus 9, then times 3. Then we're dividing by, inside of parentheses, we have negative 10 minus 22 plus 18 plus the absolute value of negative 5. All right, so it doesn't matter if we start inside of these brackets or these parentheses. As long as we do this and this separately before we attack this division. So let's start out with the operations inside of the brackets up top. And we would start inside the parentheses, because whenever you get inside of grouping symbols, you always look for grouping symbols again, right? You're reapplying the order of operations. So we have some parentheses here with negative 18 plus 9. Negative 18 plus 9 is negative 9. And then I would multiply by 3 after that. So negative 9 times a positive 3 is a negative 27. So the result of the brackets would be negative 27. Now I'm dividing by, and then inside the parentheses I have negative 10 minus 22 plus 18 plus the absolute value of negative 5. Now, if I look inside the parentheses here, I have subtraction, addition, addition, and then I have this absolute value operation. Now I need to do the absolute value operation first, because I can't add it to something if I don't know what it is, right? So I have to figure out what is the absolute value of negative 5, and that's 5. So let's rewrite this as negative 27 divided by, and inside of parentheses we have negative 10 minus 22 plus 18, and then plus 5. Now we can add and subtract moving left to right. So I'll have negative 27 divided by, then inside the parentheses, we'll have negative 10 minus 22. So that's the same as negative 10 plus negative 22. So we know that's negative, and then 10 plus 22 is 32. So negative 32, then plus 18, then plus 5. Now, remember, addition is commutative. So what that means is that I can change the order around as much as I want. If I just have addition present, I could do 18 plus 5 first, because those two numbers are positive. So I'm going to just reorder this to 18 plus 5 plus negative 32. And I'm going to do 18 plus 5 first, again, because they're positive numbers, and that would give me 23. So I'd have negative 27 divided by, inside of parentheses, I'd have 23, and then plus a negative 32. Okay, so now we want to do 23 plus negative 32. So we know the sign is going to be negative, because negative 32 has the larger absolute value. Then what I'm going to do is I'm going to subtract 32 minus 23, and that's going to give me 9. Right? I would borrow here. 12 minus 3 is 9. So we have one final operation to perform. We have negative 27 divided by negative 9. Negative divided by negative is positive. 27 divided by 9 is 3. So we end up with 3 as our answer. Hello and welcome to Pre-Algebra Test Section 5 on the order of operations with integers. Okay, so we just want to evaluate each. And we're just looking at one problem here. Inside of brackets, we have negative 23 minus, and then inside of parentheses, we have 8 plus negative 12 times 2 minus 1 minus 12. Then we're dividing by, we have this quantity here, negative 21 minus a negative 20. So we have multiple grouping symbols involved. We have these brackets here, and we have these parentheses here. So it doesn't matter which one I start inside of, as long as I do them separately before I perform this division. I'm okay. So if I start inside the brackets, I look for the innermost set of parentheses. So that occurs right here. Okay? And I know you see parentheses around negative 12. Again, that's just so that we don't have a plus and then a minus next to each other without some separation. That's all those parentheses are for. Now, if I start inside the parentheses here, I have addition, multiplication, subtraction, and subtraction. I want to multiply first. So what is negative 12 times 2? That's negative 24. So this right here would be negative 24. And then I would just add and subtract moving left to right. So I'd have 8 plus negative 24. That would be negative 16. And then I would subtract away 1. that would be negative 17. That's like adding negative 1. And then I would subtract away 12. So I'd have negative 17 plus negative 12. So just think about the answer would be negative, and then 17 plus 12 is 29. So now that we know that the result of what's inside the parentheses here is negative 29, I can just write inside of brackets negative 23. I'd have minus a negative 29, which is plus 29. And then we're dividing by, inside the parentheses here, I'd have negative 21 minus a negative 20, we can write as plus 20. Remember, minus a negative is plus a positive. So now, inside the brackets, negative 23 plus 29 is positive 6. So I'd have 6 divided by, inside the parentheses here, negative 21 plus 20 is negative 1. So divided by negative 1. And just do this division. If you multiply or you divide by negative 1, you just change the sign of the number. So starting with 6, it's positive. If I divide by a negative 1, it becomes negative. So it's just negative 6.